The Big Bang did not bang. Let that sink in for a moment. The most fundamental creation story of modern science, the one you've heard countless times, is misnamed. There was no explosion, no sound echoing through empty space, no flash of light, piercing an ancient darkness. In fact, there was no space for an explosion to occur within, no time for a sound to echo through, no darkness for light to illuminate. You've been told a simplified story, a metaphor that has calcified into presumed fact. But the truth about the beginning of time is far stranger, far more unsettling than you've been led to believe. What if I told you that asking when time began is like asking what's north of the North Pole? That our universe might be just one breath in an eternal cosmic respiration? That the very concept of before the universe might be as meaningless as asking what exists outside of existence? Would you believe me if I said that physics itself, the bedrock laws governing reality as you know it, might have evolved like biological organisms? That the constants you learned in school, gravity, electromagnetism, the speed of light, might once have been as fluid and changeable as water? But I'm getting ahead of myself. Or perhaps behind myself. In a discussion about the origin of time, the language of before and after becomes treacherously inadequate. Close your eyes. Imagine you could rewind the cosmic film reel of existence. Every galaxy rushing backward, stars unforming, planets dissolving into cosmic dust, atoms unbinding, until finally... Symmetry. What? A singularity? A quantum fluctuation? A collision of higher dimensional membranes? Or something even stranger? A reality where time itself dissolves, where cause and effect become meaningless concepts? This is the journey we're about to undertake, not just through space and time, but perhaps beyond them both. You might be wondering why this matters. After all, you exist now, in this moment, bound by the forward arrow of time that carries you inexorably from birth toward death. What difference does it make how time began billions of years ago? But consider this. You are made of star stuff, as Carl Sagan famously noted. The atoms in your body were forged in stellar furnaces that existed billions of years ago. The energy animating your cells traces back to the earliest moments of cosmic history. You are not separate from this story. You are its current embodiment, its living continuation. Understanding time's beginning isn't just cosmology, it's autobiography. And so we begin at what appears to be the beginning, though we'll soon discover how problematic that concept really is. 13.8 billion years ago, give or take a cosmic blink, our observable universe emerged from a state of extreme density and temperature, a state so alien to human experience that our most sophisticated mathematics struggles to describe it. A state where the familiar forces of nature were unified, where the distinction between energy and matter dissolved, where space and time themselves were warped beyond recognition. But already I've slipped into telling the conventional story, using words like emerged and ago that presuppose the existence of time as we know it. Let's try again, more carefully, this time. Imagine a point on the surface of an inflating balloon. As the balloon expands, the point moves farther away from all other points. Now imagine you're a two-dimensional being living on that balloon's surface. You have no concept of the third dimension, no awareness of the balloon itself. All you know is that everything in your universe seems to be moving away from everything else. This is similar to our cosmic situation. We observe galaxies moving away from each other and trace this expansion backward in time to infer a moment of extreme compression. But just as the surface of a balloon doesn't begin at any particular point, it simply expands from a previous state. The universe, as we understand it, might not have begun in the conventional sense. What we call the Big Bang might better be described as the Big Stretch, a rapid expansion of space itself, carrying energy with it that would eventually cool and condense into the matter that forms stars, planets, and eventually the complex chemistry that allows you to exist and contemplate these very questions. But this analogy, like all analogies, attempting to capture cosmic birth, eventually breaks down. The balloon has a center, existing in a higher dimension that its surface dwellers cannot perceive. Does our universe exist within some higher dimensional reality? Is what we call the beginning of time merely a transition point, a phase change in some larger cosmic context we cannot directly observe? These questions take us to the razor's edge of modern physics, where competing theories offer radically different visions of time's origin. According to classical general relativity, Einstein's masterwork that describes gravity as the curvature of spacetime, tracing the universe, backward leads inexorably to a singularity, a point of infinite density where the equations themselves break down. It's as if reality itself hits a mathematical wall, beyond which our current understanding cannot penetrate. But nature abhors both infinities and ignorance. Enter quantum mechanics, the physics of the very small, which suggests that at extremely tiny scales and enormous energies, reality becomes probabilistic rather than deterministic. Particles pop in and out of existence. Cause and effect. Blur. The sharp edges of classical physics dissolve into a foam of quantum possibilities. When we attempt to merge these two pillars of modern physics, general relativity and quantum mechanics, to understand the extreme conditions of the early universe, we enter uncharted theoretical territory. This is the realm of quantum gravity, perhaps the greatest unsolved problem in theoretical physics. Some approaches, like string theory, propose that everything in the universe, from particles to forces, consists of tiny vibrating strings or higher dimensional objects, vibrating in dimensions beyond the three spatial ones we directly experience. In some versions of string theory, our universe might have emerged from a collision between higher dimensional branes, cosmic membranes existing in a larger bulk space. Others, like loop quantum gravity, suggest that space-time itself has a discrete, granular structure at the smallest scales, a quantum geometry that prevents the formation of a true singularity and potentially allows the universe to bounce from a previous contracting phase into our current expanding one. Still others propose that our universe is just one of many in a vast multiverse, each with potentially different physical laws, emerging through eternal cosmic inflation or through black holes giving birth to new universes in their interiors. These aren't just abstract, mathematical games. They represent our most ambitious attempts to understand reality at its most fundamental level, to peer beyond the veil of the observable and grasp the true nature of existence itself. But here's where the story gets truly strange. In many of these theories, time as we understand it, the orderly progression from past to future, the stage upon which cause precedes effect, may not be fundamental at all. It might be an emergent property, a large-scale approximation that breaks down at the universe's birth, just as Newtonian physics breaks down at relativistic speeds or quantum scales. Some physicists have even proposed that time might be entirely absent from the most fundamental equations describing reality. In the Wheeler-DeWitt equation, an attempt to quantize gravity, the universe as a whole is described by a timeless wave function. Time emerges only when we focus on subsystems within the cosmos, much as temperature emerges when we consider the collective behavior of particles, despite not being a property of any individual particle. If these ideas hold true, then asking, "How did time start?" might be fundamentally misconceived, like asking about the temperature of a single electron. Time might not have started at all. It might simply become a meaningful concept once the universe reaches a certain level of complexity and organization. Consider the implications of this for a moment. Every culture throughout human history has created origin stories, narratives that attempt to explain how everything began. From ancient creation myths to modern scientific cosmology, we've sought to understand our beginnings, to trace causality back to some first cause. But what if the concept of a first cause is itself an artifact of our time-bound consciousness? What if, at the deepest level of reality, there is no beginning or end, just a timeless mathematical structure from which our experience of temporal flow emerges? This isn't mere philosophical speculation. The equations of physics, when pushed to their limits, point toward precisely such possibilities. The distinction between past, present, and future, which seems so fundamental to human experience, may be, in Einstein's words, only a stubbornly persistent illusion. You might wonder, then, if time is in some sense illusory, why do we experience it so powerfully? Why does causality seem to flow in one direction? Why can we remember the past but not the future? The answer appears to lie in entropy, the tendency of ordered systems to become disordered over time. When you drop an egg, it breaks, spattering yolk across the floor. You never see the reverse. Scattered egg fragments spontaneously assembling into a perfect shell with yolk contained within. This asymmetry, this arrow of time pointing from past to future, from order to disorder, may explain why we experience time's flow as we do. Our memories form as neural patterns are etched in our brains, increasing entropy. The future remains unformed, with multiple possible outcomes that haven't yet collapsed into the single reality we call the past. But this entropy-driven arrow exists within time. It doesn't explain time's origin. For that, we must venture even deeper, to the realm where quantum mechanics and gravity converge. In the first fraction of a second, after what we conventionally call the Big Bang, a time span so brief it makes a millisecond seem like an eternity, our universe underwent changes so profound they challenge comprehension. During the Planck epoch, lasting from the beginning until 10^42 seconds later, a time interval so short there's no adequate analogy in human experience, quantum effects dominated even gravity. Space and time themselves may have been subject to quantum fluctuations, forming a roiling quantum foam where certainty itself dissolved. This is the domain where our current physics breaks down completely, where the nature of time becomes most questionable. Did time emerge from timelessness here? Did it fluctuate into existence as a quantum variable? Was it born from some higher dimensional reality? Following this came the Grand Unification Epoch, lasting until 10^36 seconds. where three of the four fundamental forces, the electromagnetic, the weak, nuclear, and the strong nuclear, were potentially unified as a single force. Only gravity remained distinct. Then, in an unimaginably brief moment between 10^36 and 10^32 seconds, the universe underwent what cosmologists call cosmic inflation, an exponential expansion that increased its size by a factor of at least 10^26. What had been smaller than a subatomic particle expanded to the size of a grapefruit almost instantaneously. This wasn't ordinary expansion. Space itself stretched, carrying energy with it, smoothing out irregularities while preserving quantum fluctuations that would eventually give rise to the galactic structures we observe today. Inflation represents one of the most dramatic events in cosmic history, yet it occurred in a time span our minds cannot meaningfully grasp. After inflation came the electro-weak epoch, when the electromagnetic and weak nuclear forces separated, followed by the quark epoch, when quarks and gluons formed a plasma too hot for protons and neutrons to exist. Only after the universe had aged a full microsecond, 10^6 or 6 seconds, did protons and neutrons form. After 3 minutes, the first atomic nuclei appeared, and only after 380,000 years did the universe cool enough for atoms to form and light to travel freely, creating the cosmic microwave background radiation. The oldest light we can directly observe, the closest thing we have to a photograph of the infant universe. These earliest epochs represent the frontier of our understanding, where observation meets theory, where evidence becomes increasingly sparse, and where the nature of time itself becomes most questionable. But perhaps I've been approaching this all wrong. Perhaps focusing solely on physics misses something essential about time's nature. After all, time isn't just a parameter in equations. It's the medium of experience, the river carrying consciousness from moment to moment. Consider this. Without consciousness, would time exist in any meaningful sense? If there were no observers to mark change, to form memories of what came before, and anticipate what comes after, would the progression from past to future have any significance? Some philosophers argue that consciousness and time are inextricably linked, that our awareness of duration, of the flow from one moment to the next, is what gives time its reality. In this view, the question of time's beginning becomes entangled with questions about the emergence of consciousness itself. Others suggest that time might be more fundamental than consciousness, that even in a universe devoid of observers, processes would unfold in a temporal sequence. A star would still form, burn, and die, whether or not anyone watched it happen. Modern physics offers yet another perspective, that past, present, and future all exist equally in a four-dimensional block universe. From this viewpoint, time doesn't flow. Rather, our consciousness moves along a dimension of space-time, perceiving different slices of this eternal block as now. If this block universe view is correct, then time never started at all. The entire cosmic history, from the Big Bang to the heat death of the universe, simply exists as a complete geometric object. Our sense of time's flow would be a psychological phenomenon, not a fundamental aspect of reality. But this view creates its own paradoxes. If the future already exists in some sense, what becomes of free will? If the end is already written alongside the beginning, is the cosmic story already complete? And if time is truly fundamental, not emergent, then what existed before the first moment? Was there a state of timelessness? Can timelessness even be said to exist or precede anything, given that existence and precedence are temporal concepts? These questions stretch language to its breaking point. We find ourselves trying to describe what might lie beyond time using words and concepts that presuppose time's existence. It's like trying to explain color to someone who has been blind from birth. Our conceptual vocabulary simply may not be adequate to the task. Perhaps that's why so many traditions throughout human history have turned to paradox and poetry when contemplating cosmic origins. The Tao Te Ching opens with, "The Bei Tao that can be told is not the eternal Tao." Buddhist texts speak of beginningless time. The biblical Genesis describes a God speaking light into existence before the creation of the sun or stars, a metaphorical truth that resonates with modern cosmology's description of the early universe as a sea of radiation. These aren't mere primitive attempts at physics. They represent intuitions about the limitations of literal language when confronting ultimate questions. Limitations that modern physics is rediscovering through its own mathematical language. When we ask how time began, we stand at the intersection of physics, philosophy, and even mysticism. We confront the limits, not just of our knowledge, but potentially of knowledge itself, at least knowledge as we currently conceive it. But rather than seeing these limits as barriers, we might view them as invitations, gateways to new ways of thinking that might eventually bridge the gap between our time-bound experience and the timeless reality that our equations hint at. For instance, some theoretical physicists are exploring whether quantum entanglement, Einstein's spooky action at a distance, might play a role in the emergence of time. When particles become entangled, they form a single quantum system regardless of the distance between them. Their properties become correlated in ways that appear to transcend space and time. Could the massive network of quantum entanglements in our universe somehow give rise to the directional flow we experience as time? Others suggest that gravity itself might be an emergent force, not fundamental, perhaps arising from quantum information theory or thermodynamics. If gravity emerges, might space-time itself, including the temporal dimension, also be emergent rather than fundamental? These speculations represent the cutting edge of theoretical physics, where our most advanced mathematics strains against the boundaries of the conceivable. They remind us that our understanding of time's beginning remains provisional, a work in progress, rather than a settled conclusion. And perhaps that's as it should be. Perhaps the greatest value in contemplating time's origin lies not in arriving at final answers, but in the expansion of imagination that occurs when we grapple with such profound questions. After all, we are time-bound creatures attempting to comprehend what might transcend time itself. That we can even formulate such questions, that we can use mathematics to probe aspects of reality far removed from our direct experience, stands as one of humanity's most remarkable achievements. As you consider these ideas, remember that you yourself are a temporal miracle, a conscious being capable of remembering the past, experiencing the present, and anticipating the future. Your very ability to contemplate time's beginning represents the universe becoming conscious of itself, the cosmos' evolving complexity sufficient to question its own origins. In that sense, perhaps the most profound answer to how time began lies not in the distant past, but in the present moment of awareness, in the remarkable fact that the universe has evolved beings capable of asking such questions in the first place. The journey of cosmic time has led, through processes both random and lawful, to this moment of contemplation. Through you, the universe questions itself. Through you, time becomes aware of its own mysterious nature. And so our exploration continues, even as the question itself evolves. For as we peer deeper into cosmic origins, we discover that what began as a seemingly straightforward question, how did time start in the universe, transforms into something far more profound. What is the nature of time itself? What does it mean for anything to begin? And what is our place, as conscious observers, in this vast temporal tapestry? These questions have no easy answers, but in contemplating them, we participate in one of the most ancient and distinctly human activities, wondering about our cosmic origins, attempting to locate ourselves within the grand narrative of existence. The story of time's beginning, it turns out, is also our story, and like all the best stories, it remains partially told, full of mystery, waiting for future chapters to unfold. But I'm getting ahead of myself again. Let's return to the physics, to what we can say with some confidence about the earliest moments of our universe, while keeping in mind the profound uncertainties that hover at the edges of our understanding. If we trace cosmic history backward, we eventually reach a state of extreme density and temperature. A state where quantum effects dominated and classical concepts of space and time lose meaning. This is the realm of quantum gravity, where our two most successful physical theories, general relativity and quantum mechanics, come into conflict. General relativity describes gravity as the curvature of spacetime caused by mass and energy. It works brilliantly at large scales, predicting phenomena like the bending of light around massive objects and the existence of black holes. But it also predicts its own failure at the beginning of the universe, where matter and energy become infinitely concentrated at what mathematicians call a singularity. Quantum mechanics, meanwhile, describes the behavior of matter and energy at the smallest scales, where particles behave as both waves and particles, where position and momentum cannot be simultaneously determined with perfect precision, where probability replaces certainty. It has proven extraordinarily successful in its domain, but it has not yet been fully reconciled with gravity. When we attempt to describe the extreme conditions near the beginning of the universe, we need a theory that incorporates both quantum mechanics and gravity. A theory of quantum gravity. And, here, we enter theoretical territory that remains unsettled. String theory proposes that the fundamental entities in nature are not point particles, but tiny vibrating strings, whose different modes of vibration manifest as different particles and forces. These strings exist in more dimensions than the 3 spatial dimensions we directly perceive, typically 10 or 11, with the extra dimensions compactified or curled, up so tightly they escape detection. In some versions of string theory, our universe might have originated from a collision between higher dimensional branes, short for membranes, floating in a higher dimensional space. This brain cosmology offers a radical reimagining of cosmic origins, suggesting our universe might be just one of many existing in a higher dimensional bulk. Loop quantum gravity, another approach to quantum gravity, suggests that spacetime itself has a discrete, granular structure at the smallest scales. According to this theory, there is a minimum possible length, the Planck length, about 10 to 35 meters, below which the concept of distance loses meaning. Similarly, there might be a minimum possible duration, the Planck time, about 10 to 43 seconds, below which the concept of time loses meaning. In some versions of loop quantum gravity, the Big Bang is replaced by a Big Bounce, where a previous contracting universe reached a minimum size before rebounding into our expanding one. Time, in this view, might extend infinitely into the past as well as the future, with our beginning merely marking a transition point rather than an absolute origin. Causal set theory takes yet another approach, proposing that spacetime consists of discrete elements connected by causal relationships. In this view, the flow of time emerges from the causal structure of events, much as a river's flow emerges from the collective movement of countless water molecules. These competing theories of quantum gravity offer different visions of time's nature and origin, but they share a common implication. What we call the beginning of time might not be an absolute beginning at all, but rather a transition point, a boundary of our observable universe, or a limit of our current understanding. This has profound implications for how we think about cosmic origins. Question: what came before the Big Bang might be meaningless in some frameworks, meaningful but currently unanswerable in others, and potentially answerable with solutions that radically reshape our conception of time itself. For instance, if the universe underwent a big bounce, then the answer to what came before is simply another phase of the universe, contracting rather than expanding. If our universe emerged from a collision between branes in a higher dimensional space, then the answer involves entities existing in dimensions beyond our direct experience. If time itself is emergent rather than fundamental, then the concept of before the beginning might be as meaningless as asking what's north of the North Pole. These possibilities remind us that our intuitions about time, shaped by everyday experience, may be inadequate guides when contemplating cosmic origins. The beginning of the universe might be less like the start of a story and more like the edge of a map, beyond which different rules apply, or our current conceptual vocabulary breaks down. Yet, despite these profound uncertainties, cosmologists have made remarkable progress in understanding the early universe. The discovery of the cosmic microwave background radiation, the afterglow of the Big Bang, provides direct evidence of a hot, dense early state. The abundance of light elements like hydrogen, helium, and lithium matches predictions of Big Bang nucleosynthesis, the process by which these elements formed in the first few minutes of cosmic history. The large-scale structure of the universe, the distribution of galaxies across space, bears the imprint of quantum fluctuations from the earliest moments, magnified by cosmic inflation, and the ongoing expansion of the universe, first discovered by Edwin Hubble in the 1920s, provides the crucial clue that led cosmologists to the Big Bang theory in the first place. These observational pillars support our broad understanding of cosmic history, even as the nature of the very beginning remains shrouded in theoretical uncertainty. Says T.Y. Waite, our instruments grow more sensitive, and our theories more sophisticated. We continue to push the boundaries of knowledge backward in time, closer to that elusive moment when time itself might have emerged from timelessness. The Large Hadron Collider recreates conditions similar to those that existed a tiny fraction of a second after the Big Bang, allowing physicists to study how matter behaved in the extreme heat and density of the early universe. Space-based observatories like the James Webb Space Telescope peer deeper into space and further back in time, revealing galaxies that formed when the universe was just a few 100 million years old. These technological marvels extend our senses beyond their natural limits, allowing us to gather evidence that constrains our theories and guides our understanding of cosmic origins. They represent humanity's collective effort to answer the most profound questions about our existence. Where did we come from? How did the universe begin? What is the nature of time itself? But as we pursue these questions, we must remain mindful of the limitations inherent in our inquiry. We are time-bound creatures attempting to comprehend what might transcend time. We use mathematics and language, symbolic systems developed within time, to describe what might lie beyond time's boundaries. This creates an inescapable tension in our quest for understanding. We seek definitive answers about cosmic origins, yet the deeper we probe, the more we discover the provisional nature of our knowledge, the extent to which our conceptual frameworks may be inadequate to the task. Perhaps this tension itself offers a clue about the relationship between consciousness and cosmic origins. Perhaps the universe evolves not just matter and energy, but understanding itself, consciousness, capable of contemplating its own source. In that case, the question of how time began becomes not just a scientific inquiry, but an invitation to expand our consciousness, to develop new ways of knowing that might eventually bridge the gap between our time-bound experience and the timeless reality that our equations hint at. This perspective reminds us that the scientific exploration of cosmic origins, remarkable as it is, represents just one approach to a question that has inspired human contemplation across cultures and throughout history. Ancient myths and religious traditions offer narratives of cosmic origins that, while not scientific in the modern sense, capture intuitions about the mystery of existence, the relationship between time and eternity, the emergence of order from chaos. Philosophical traditions, from Aristotle's unmoved mover to Kant's transcendental idealism to Heidegger's reflections on being and time, offer conceptual frameworks for thinking about beginnings, causality, and the nature of time itself. Even artistic explorations, from Michelangelo's creation of Adam to Stanley Kubrick's 2001, A Space Odyssey, offer ways of engaging with cosmic origins that speak to aspects of the question that science alone might not address. These diverse approaches remind us that the question of time's beginning resonates across the full spectrum of human inquiry, engaging not just our intellect, but our imagination, our sense of meaning, our capacity for wonder. And perhaps that's the most profound implication of the question itself. That in asking how time began, we express something essential about what it means to be human, to be creatures bound by time yet capable of contemplating timelessness, beings emerging from the cosmos yet able to reflect on cosmic origins. In this light, the scientific exploration of time's beginning appears not as a dry academic exercise, but as the contemporary expression of humanity's perennial quest to understand our place in the cosmic story, to locate ourselves within the vast expanse of space and time, to comprehend the matrix from which we emerged. And while our understanding remains incomplete, the journey itself transforms us. In contemplating how time began, we expand our consciousness, develop new conceptual frameworks, and perhaps glimpse, however dimly, aspects of reality that transcend our ordinary experience. This transformative potential reminds us that the value of the question lies not just in the answers we might eventually discover, but in the expansion of mind and spirit that occurs when we grapple with such profound mysteries. So, as we continue our exploration of how time began in the universe, let us proceed with both scientific rigor and philosophical humility, mindful of the limitations of our understanding, yet committed to pushing its boundaries. Aware that in questioning the beginning of time, we participate in one of the most distinctly human activities, wondering about our origins, contemplating the nature of reality, and seeking to comprehend the incomprehensible. The story of time's beginning, it turns out, is also the story of humanity's awakening to the wonder of existence. And like all the most profound stories, it remains partially told, full of mystery, waiting for future chapters to unfold. Time flows like a river. This is how we've come to understand it. An endless stream carrying us forward moment by moment, from the cradle to the grave, from the formation of stars to their eventual collapse. We navigate its currents, mark its passage, build our lives around its rhythms. Time feels fundamental, irreducible, the backdrop against which everything else unfolds. But this familiar picture, this comfortable intuition about time's nature, begins to dissolve when we venture into the deeper waters of modern physics, where time reveals itself to be something far stranger than our everyday experience suggests. Let's begin with something most of us learned in school. Light travels at approximately 300,000 kilometers per second. The cosmic speed limit, enshrined in Einstein's theories as a universal constant. Nothing can travel faster, and this single fact reshapes our entire understanding of time. Because light's speed is finite, looking into deep space means looking into the deep past. The light from Andromeda, our nearest galactic neighbor, takes 2.5 million years to reach us. When you gaze at Andromeda through a telescope, you're seeing it not as it exists now, but as it existed when our ancestors were first crafting stone tools on the African savanna. The light from distant quasars has been traveling for billions of years before reaching our telescopes. These ancient beacons show us the universe as it was when the Earth itself didn't yet exist, when even our sun had not yet condensed from its nebular cloud. This telescoping of time and space creates what we call the observable universe, that portion of the cosmos from which light has had sufficient time to reach us since the Big Bang. Beyond this cosmic horizon lies space we cannot see, not because it doesn't exist, but because its light hasn't had time to reach us during the universe's 13.8 billion-year history. The observable universe is not merely a spatial boundary, but a temporal one. And this raises a profound question. If the observable universe is bounded by time, what lies beyond that boundary? Is it more space, more time, or something else entirely? Consider a curious fact. Every observer, no matter where they are in the cosmos, finds themselves at the center of their own observable universe. This isn't because the universe has multiple centers, but because the speed of light creates a spherical boundary of observation unique to each vantage point. The universe itself has no center. A statement that challenges our deepest intuitions about space. After all, if something expands, surely it expands from somewhere. Yet cosmological expansion isn't like an explosion radiating outward from a central point. Rather, it's space itself that stretches, carrying galaxies along like raisins in rising dough. And if the universe has no center in space, can it have a beginning in time? If time and space are intimately connected, woven together into what Einstein called spacetime, does the absence of a spatial center hint at something profound about the nature of the temporal beginning? These questions push us toward one of modern cosmology's most counterintuitive discoveries. The Big Bang wasn't an explosion in pre-existing space and time. It wasn't an event that happened at a particular location. It was the simultaneous emergence of space, time, matter, and energy. The beginning of everything we observe, including the dimension of time itself. But what does it mean for time to begin? Can we even formulate such a concept coherently? The The renowned physicist Stephen Hawking posed the question this way: asking what came before the Big Bang is like asking what's north of the North Pole. The question itself contains a conceptual error. Just as north ceases to be a meaningful direction once you reach the pole, before may cease to be a meaningful concept when you reach the beginning of time. This analogy offers a glimpse into the conceptual revolution that modern cosmology demands of us. We must let go of our intuitive understanding of time as an external, ever-flowing river, and instead confront the possibility that time itself is contingent, emergent, perhaps even illusory in a fundamental sense. Let's explore what modern physics tells us about the early universe. Not just the facts and figures, but the profound implications for our understanding of time's nature and origin. The earliest epoch we can theoretically describe begins at the Planck time, 10 to 43 seconds after what we conventionally call the beginning. This incomprehensibly brief moment is named after Max Planck, the founder of quantum theory, and represents the smallest unit of time that has physical meaning within our current theories. Before the Planck time, our equations break down entirely. Our concepts of space and time lose coherence. We enter a domain where quantum gravity would reign, if we had a complete theory, which we don't. The universe at the Planck time was not merely hot. It was a furnace where the very concept of temperature strains, meaning where energy densities approached infinity, where space and time themselves writhed and foamed with quantum fluctuations. This was not just a different state of the universe, it was almost a different kind of existence altogether. In this seething quantum inferno, the four fundamental forces of nature, gravity, electromagnetism, the strong nuclear force, and the weak nuclear force, were possibly unified into a single, primordial force. The distinctions we observe today between these forces, as fundamental as they seem, may be low-energy artifacts of a deeper unity that manifested only in the extreme conditions of the nascent cosmos. As the universe expanded and cooled, terms that themselves require careful qualification when applied to this alien epoch. These forces separated in a series of cosmic phase transitions, similar to how water can exist as vapor, liquid, or solid, depending on temperature and pressure. Separation of gravity from the other forces occurred first, followed by the strong nuclear force, leaving the electromagnetic and weak nuclear forces still unified as the electro-weak force. This symmetry-breaking choreography reshaped the physical laws governing the universe, establishing the rulebook that would later allow for the formation of stable matter. But here's where our cosmic story takes its most dramatic turn. At approximately 10:36 seconds after the beginning, something extraordinary happened. Something that would fundamentally reshape the universe and establish the conditions necessary for everything that followed, including our eventual existence. The universe entered a phase of exponential expansion called cosmic inflation. During this brief but crucial period, lasting only until about 10:32 seconds, the universe expanded faster than the speed of light. Not because anything was moving through space at superluminal speeds, but because space itself was stretching at an accelerated rate. The inflationary epoch expanded the universe by a factor of at least 10 to 26 in an unimaginably brief moment. If we could somehow visualize this process, we would see what was initially a subatomic scale universe suddenly balloon to the size of a grapefruit. Nothing in our everyday experience provides an adequate analogy for such explosive growth. Inflation solved several cosmological puzzles that had plagued earlier models of the Big Bang. It explained why the universe appears flat rather than curved, why it's so homogeneous on large scales, and why we don't observe magnetic monopoles. exotic particles predicted by certain unified theories but never detected. But inflation does more than solve technical problems in cosmology. It fundamentally alters how we think about cosmic origins and the nature of time itself. For one thing, inflation suggests that our observable universe, the part of the cosmos from which light has had time to reach us, may be just a minuscule fraction of a much larger, perhaps infinite, universe. The observable universe, vast as it seems to us, might be like a single bubble in a vast cosmic foam, a small region where inflation has ended, while it continues elsewhere. This inflationary multiverse scenario raises profound questions about beginnings. If inflation is eternal in some regions of the cosmos, always spawning new bubble universes, does the concept of an absolute beginning even make sense? Could our universe's beginning be merely a local event in a much grander cosmic context that has no beginning or end? After inflation subsided in our region of the cosmos, the universe entered a phase of more gradual expansion. The enormous energy that had driven inflation was converted into particles and radiation through a process called reheating, raising the temperature of the universe dramatically and filling it with a hot plasma of elementary particles. This marks the beginning of the hot Big Bang phase familiar from traditional cosmology, but now understood as the aftermath of inflation, rather than the absolute beginning of everything. In this superheated cosmic broth, particles and antiparticles formed and annihilated continuously. For every particle of matter, a corresponding antiparticle of antimatter was created. These pairs would then reunite and vanish in flashes of pure energy, only to be reborn from the energy bath in an endless cycle of creation and destruction. If matter and antimatter had remained in perfect balance, they would have completely annihilated each other, leaving a universe filled with radiation but no matter, no galaxies, no stars, no planets, no life, but a subtle asymmetry existed, for reasons still not fully understood, that allowed matter to slightly outnumber antimatter by roughly 1 part in a billion. This tiny imbalance, this cosmic accounting error, would prove crucial for everything that followed. As the universe continued to expand and cool, reaching about 1 second of age, protons and neutrons formed from their constituent quarks. By 3 minutes, these protons and neutrons had combined to form the nuclei of the lightest elements, primarily hydrogen, with about 25% helium and trace amounts of lithium. This process of primordial nucleosynthesis provided the raw material from which the IBG first stars would eventually form, but the universe was still too hot for atoms to exist. Electrons remained free, constantly interacting with photons of light, making the universe opaque, a foggy, glowing plasma through which light could not travel freely. Only after 380,000 years of expansion and cooling did the temperature fall enough for electrons to combine with nuclei, forming the first complete atoms. This moment, known as recombination, transformed the universe from opaque to transparent. Light, previously trapped in constant interaction with free electrons, could suddenly travel unimpeded across space. This liberated light forms what we now observe as the cosmic microwave background radiation, the afterglow of the Big Bang, the oldest light in the universe. When we detect this radiation, we're seeing the universe as it existed 380,000 years after its beginning. A baby cosmos just emerging from its luminous fog. The cosmic microwave background provides our earliest direct observational window into the universe's history. It shows us a remarkably uniform cosmos, with tiny temperature fluctuations, just 1 part in 100,000, that would later grow into the vast cosmic structures we observe today. These minute variations in temperature reflect quantum fluctuations from the earliest moments. Microscopically, small ripples in spacetime that inflation stretch to macroscopic scales. What began as quantum jitters in the universe's first instant became the seeds of galaxies, the blueprint for cosmic structure. After recombination, the universe entered what cosmologists call the Dark Ages, a period lasting hundreds of millions of years when no stars or galaxies yet existed to illuminate the cosmos. Hydrogen and helium gas, initially distributed almost uniformly, gradually clumped together under gravity's influence, forming denser and denser regions. Eventually, roughly 200 million years after the Big Bang, these gas clouds reached sufficient density for nuclear fusion to ignite at their centers. The first stars blazed to life, ending the cosmic dark ages and beginning the process of stellar nucleosynthesis that would forge the heavier elements essential for planets and life. These first stars were giants, hundreds of times more massive than our Sun, burning hot and dying young in spectacular supernova explosions that scattered newly created heavy elements across space. These stellar cataclysms enriched the interstellar medium with carbon, oxygen, silicon, iron, the building blocks of rocky planets, and eventually of life itself. Over billions of years, generations of stars lived and died, each contributing to the universe's growing chemical complexity. Galaxies formed and merged, supermassive. Black holes grew at galactic centers. Planets coalesced around new stars, and on at least one such planet, a pale blue dot orbiting an ordinary star in an unremarkable galaxy, complex chemistry eventually gave rise to biology, to consciousness, to beings capable of looking up at the night sky and asking, where did it all begin? This cosmic narrative, from quantum fluctuations to conscious contemplation, represents one of science's greatest achievements. Yet even as we trace cosmic history with increasing precision, the question of the beginning itself remains elusive, hovering at the edge of what our theories can meaningfully describe. And this brings us back to the nature of time. The standard cosmological model describes the evolution of the universe from a tiny fraction of a second after the Big Bang, but it doesn't, and perhaps can't, tell us about the beginning itself, or whether beginning is even the right concept. To understand why, we need to examine the relationship between time and the laws of physics more carefully. In our everyday experience, time seems to flow independently of the material world. We imagine we could remove all objects from the universe, and time would continue to tick along regardless. But Einstein's theories of relativity demolished this intuitive separation between time and the material world. In general relativity, space and time aren't just the stage on which physics plays out. They are active participants in the drama. Massive objects bend space-time, and this curvature tells matter how to move. The mutual dance between matter and space-time means that time itself is shaped by the distribution of mass and energy in the universe. Time doesn't tick at the same rate throughout the cosmos. It flows more slowly in strong gravitational fields, a phenomenon we verified through precision measurements. This variable flow of time reaches its ultimate expression in a black hole, where space-time curvature becomes so extreme that time effectively stops at the event horizon as observed from the outside. Beyond the horizon, at the center of the black hole, our theories predict a singularity, a point where space-time curvature becomes infinite, and the laws of physics break down entirely. Similar mathematics describes the Big Bang as a singularity in the past, a point where density and temperature become infinite, and the concepts of space and time lose meaning. But a crucial difference exists. While we can observe black holes from the outside, remaining safely in the domain where our physics works, we cannot stand outside the Big Bang. We are within the cosmic horizon, attempting to peer back at our own origin. This observation underscores a profound limitation. Our physical theories describe relationships between observables within the universe. They presuppose the existence of space, time, and physical laws. When we try to apply these theories to the beginning of everything, including space, time, and the laws themselves, we're stretching them beyond their domain of validity. It's like trying to use the rules of a board game to explain how the board and pieces came into existence in the first place. The rules operate within the game. They can't explain the game's origin. This limitation has led some physicists to ask, are we even asking the right questions about cosmic origins? Perhaps the concept of a beginning in time isn't the most fundamental way to think about the universe's existence. One alternative approach treats the universe as a quantum system, described by a wave function. In quantum mechanics, particles don't follow single, definite trajectories. Instead, their behavior is described by probability waves that encompass all possibilities until measurement collapses them to specific outcomes. Applied to the universe as a whole, this quantum cosmology suggests that the cosmos might exist in a superposition of different possible histories, different possible beginnings, with varying probabilities. Our observed cosmic history, with its particular beginning and evolution, would be just one realization from this quantum ensemble. This perspective transforms the question, how did time begin? Into something more like, why do we observe this particular cosmic history rather than another? It replaces a singular, definitive beginning with a quantum superposition of possibilities. Another approach, inspired by string theory, envisions our universe as a lower-dimensional membrane, a brain floating in a higher-dimensional space called the bulk. In this brain cosmology, our universe might have originated from a collision between brains, with the energy of the collision manifesting as the Big Bang from our perspective. This scenario doesn't eliminate the beginning, but it recontextualizes it. What appears to us as the absolute origin of everything might be just one event in a larger reality with its own temporal structure, perhaps even cyclic rather than linear. Loop quantum cosmology, derived from loop quantum gravity, offers yet another perspective. By treating space-time as fundamentally discrete rather than continuous, composed of minimum-size atoms of space and time, this approach eliminates the singularity at the Big Bang. Instead, it suggests that our expanding universe might have emerged from a previous contracting phase through a big bounce. The apparent beginning of time in our expanding phase would be connected to the end of time in a previous contracting phase, with quantum effects preventing the formation of a true singularity at the bounce point. These various approaches to quantum gravity, still theoretical, still evolving, share a common implication. What we perceive as the beginning of time might not be an absolute beginning at all. It might be a transition point, a boundary condition, or an emergent property in a deeper reality where our familiar concepts of space and time lose their meaning. But this raises a contradiction that strikes at the heart of our understanding. If the universe has no absolute beginning in time, then how did time itself come to exist? And if time had a beginning, what could it possibly mean for something to exist before time began? This paradox isn't merely a failure of language or imagination, though it certainly strains both. It points toward a fundamental limitation in our conceptual framework, suggesting that our intuitive understanding of beginnings, causes, and temporal sequence may be inadequate when applied to cosmic origins. Perhaps time itself emerges from something more fundamental, something timeless, but what could that mean? How can we even conceive of timelessness, embedded as we are in temporal experience? Various analogies might help us approach this conceptual frontier. Consider a movie stored on a disc. The entire film exists simultaneously on the physical medium, but when played, it creates the experience of temporal sequence, a beginning, middle, and end. Could our universe be similar? A complete four-dimensional structure that we experience sequentially as the now of consciousness moves through it? Or consider mathematics. The Pythagorean theorem wasn't created at a particular moment. In some sense, it has always been true, existing in a realm of logical necessity rather than temporal contingency. Could the fundamental laws of physics have a similar timeless existence, with our universe being one expression of these eternal principles? These analogies are imperfect, but they hint at possibilities beyond our temporal intuitions. They suggest that what we experience as the flow of time might be the surface manifestation of a deeper reality that transcends temporal categories altogether. The question of time's beginning thus leads us not just to the frontier of modern physics, but to the limits of human understanding itself. It challenges us to recognize how deeply our thinking is shaped by our temporal existence, how difficult it is to conceptualize reality outside the framework of before and after, cause and effect. Yet, the very fact that we can formulate these questions, that we can recognize the limitations of our temporal concepts, suggests a remarkable capacity. Though embedded in time, human consciousness can reach toward timelessness. Though finite, we can contemplate infinity. This cognitive frontier, where physics meets philosophy, where mathematics encounters metaphysics, represents the cutting edge of human inquiry into cosmic origins. And while definitive answers may elude us, the journey itself reveals something profound about the universe and our place within it. For we are not merely observers of cosmic history, passive recorders of time's flow. We are participants in the unfolding drama, products of the same processes we seek to understand. The atoms in our bodies were forged in stellar furnaces that no longer exist. The patterns of our thoughts emerge from neural structures shaped by billions of years of cosmic and biological evolution. In a very real sense, the universe has evolved the capacity to contemplate its own origins. Through consciousness, through your consciousness as you engage with these ideas, the cosmos achieves a kind of self-awareness, an ability to reflect on its own existence and evolution. This remarkable fact suggests a different way of thinking about the question of time's beginning. Perhaps the most significant aspect of cosmic history isn't the first instant, but the emergence of consciousness capable of contemplating that first instant. Perhaps the universe achieves something essential not at its temporal origin, but through the eventual evolution of minds that can reconstruct that origin through science, philosophy, art, and wonder. From this perspective, the question, "How did time begin?" is less about pinpointing an initial moment and more about understanding the entire arc of cosmic evolution, a journey that leads from simple physical processes to conscious contemplation. It's about recognizing that time itself, the dimension along which this evolution occurs, might be more complex, more mysterious, and more profound than our everyday experience suggests. As we continue our exploration, let's hold this tension between knowing and not knowing, between our temporal nature and our capacity to contemplate timelessness. For it is precisely this tension that drives scientific progress, philosophical insight, and the deepest forms of human wonder. The beginning of time remains one of the greatest mysteries in modern science, not because we lack information or theoretical frameworks, but because we approach the limits of what our current concepts can meaningfully describe. We stand at a cognitive horizon, where our temporal intuitions begin to fail, where causality itself becomes questionable, where the very framework of our understanding requires radical revision. Yet despite these profound uncertainties, we haven't reached a dead end. Rather, we've arrived at a frontier, a boundary not just of knowledge, but of the knowable as currently conceived. And like all frontiers, it beckons us to venture beyond, to develop new concepts, new mathematics, new ways of thinking that might eventually bridge the gap between our time-bound experience and the timeless reality our equations hint at. In this quest, we are guided not just by observation and experiment, but by the power of theoretical imagination. The ability to envision realities beyond our direct experience, to construct mathematical frameworks that might capture aspects of existence that transcend ordinary perception. Einstein didn't discover relativity by simply measuring the world more. Precisely, he reimagined the fundamental nature of space, time, and gravity. Quantum pioneers like Bohr, Heisenberg, and Schrödinger didn't just refine existing theories, they developed radically new frameworks for understanding reality at its smallest scales. Similarly, understanding time's beginning may require not just better instruments, but a conceptual revolution, perhaps even more profound, as it confronts not just specific aspects of physics, but the very foundation upon which all our theories are built. This may sound abstract, even philosophical, but it has concrete implications for how we approach questions of cosmic origins. It suggests that we should hold our current models, impressive as they are, with a certain tentativeness, recognizing their provisional nature, their status as approximations rather than final truths. It reminds us that the universe is not obligated to conform to our intuitions or to fit neatly within our existing conceptual categories. Reality, at its deepest levels, might be stranger than we can currently imagine, not just quantitatively more complex, but qualitatively different from our present understanding. And it invites us to cultivate a particular kind of intellectual humility. Not the resignation that declares certain questions permanently unanswerable, but the openness that recognizes the limitations of current approaches while remaining receptive to new possibilities, new frameworks, new ways of asking the questions themselves. This humility doesn't diminish the remarkable achievements of modern cosmology. On the contrary, it honors them. By recognizing both their power and their boundaries, their profound insights, and the even more profound mysteries toward which they point. For in tracing cosmic history back toward its earliest moments, in pushing our theories to their limits and beyond, we haven't simply accumulated facts about an external reality. We've engaged in a process of cosmic self-discovery, exploring not just the universe around us, but the universe that we ourselves embody. The atoms, forces, and emergent patterns that constitute our physical existence. And, in contemplating time's beginning, we confront not just an abstract scientific puzzle, but a mystery that touches the core of human experience. Our sense of transience and permanence, our awareness of mortality, and our yearning for the eternal, our experience of change, and our search for that which endures beyond change. In this sense, the scientific exploration of cosmic origins represents the contemporary expression of humanity's perennial quest to understand our place in the cosmos, to locate ourselves within the vast expanse of space and time, to comprehend the matrix from which we emerged. And while our understanding remains incomplete, the journey itself transforms us. In contemplating how time began, we expand our consciousness, develop new conceptual frameworks, and perhaps glimpse, however dimly, aspects of reality that transcend our ordinary experience. As you ponder these ideas, remember, You aren't merely a passive recipient of cosmic history. You are an active participant in its ongoing evolution, a node of consciousness through which the universe achieves a kind of self-awareness, a capacity to reflect on its own existence and origins. Your very contemplation of these questions represents something remarkable, matter that has arranged itself into patterns complex enough to contemplate its own source. Through you, the universe questions its beginning. Through you, time reflects on its own nature. And in this reflection, something new emerges. Not just knowledge, but understanding. Not just information, but meaning. Not just facts about the past, but possibilities for the future. For the story of cosmic origins isn't just about what happened then, at the dawn of everything. It's about what's happening now, in this moment of awareness, as the universe continues to evolve not just physically, but consciously, through the emergence of minds capable of reconstructing its history, comprehending its patterns, and perhaps eventually grasping even the mystery of its beginning. In that sense, the question of how time began remains open, not because we've failed to answer it, but because the answer continues to unfold, through science, through philosophy, through every act of human wonder that reaches toward the cosmos and asks, where did all this come from? How did it begin? And what does it mean that we can ask such questions at all? At the edge of our understanding, where the mathematics of space-time breaks down and our most fundamental theories fail, we find ourselves confronting a profound mystery: the origin of time itself. Not merely when time began, but how time began. Not simply the first moment, but the emergence of moments, the birth of before and after, the dawn of change, the genesis of causality. This is no abstract academic puzzle. It's the question of how possibility itself came into being, how the eternal is became the flowing was and will be. And as we'll discover, it might just be the wrong question altogether. For centuries, we've envisioned time as a cosmic clock, ticking steadily in the background, marking the universe's evolution with metronomic precision. Newton formalized this intuition, describing absolute time as flowing equably without regard to anything external. Time, in this view, existed independently of the material world, an invisible river carrying reality forward at a constant pace. Einstein shattered this comforting image. His theories of relativity revealed time to be elastic, dynamic, inseparable from space, and intimately connected to matter and energy. Time flows at different rates, depending on velocity and gravitational fields. Space and time curve in the presence of mass. The neat division between space and time dissolves into a unified space-time, a four-dimensional fabric in which the past, present, and future exist on equal footing. This was just the beginning of time's dethronement from absolute status. Quantum mechanics, the physics of the very small, introduced further complications. At quantum scales, time becomes granular, uncertain, subject to fluctuations. Particles can exist in superpositions of different times. Cause and effect blur. The arrow of time that seems so evident in our macroscopic world becomes questionable at the quantum level. These two revolutionary theories, relativity and quantum mechanics, transformed our understanding of reality in the 20th century, yet they remain fundamentally incompatible. General relativity describes a smooth, continuous space-time curved by matter and energy. Quantum mechanics describes a discontinuous reality where particles exist as probability waves until observed. When we try to combine these frameworks to understand extreme conditions, like those at the Big Bang or inside black holes, our mathematics breaks down. This incompatibility isn't just a technical problem for physicists. It hints at something deeper. Perhaps our most basic concepts of space and time are approximations, useful for describing reality at certain scales, but inadequate for capturing its fundamental nature. Consider the singularities predicted by general relativity, points where space-time curvature becomes infinite, where density and temperature soar beyond any finite value, where the laws of physics as we know them cease to function. Both the center of a black hole and the Big Bang itself are described as singularities in classical general relativity. But nature abhors infinities. Physicists generally interpret singularities not as physical realities, but as signs that our theories have reached their limits. When our equations produce infinities, they're telling us, your conceptual framework is breaking down. There's something happening here that your current mathematics cannot describe. This is why we need a theory of quantum gravity, a framework that reconciles general relativity with quantum mechanics, that can describe gravity at quantum scales and explain what happens in the extreme conditions near singularities. Several approaches to quantum gravity have been developed, each offering a different perspective on the nature of space-time and the origin of time. Let's explore these competing visions not as dry technical theories, but as radical reimaginings of reality itself, cosmic dramas playing out on the stage of fundamental physics. String theory proposes that the most basic constituents of reality aren't point-like particles, but tiny vibrating strings. These strings vibrate in multiple dimensions, not just the 3 spatial dimensions and 1 time dimension we directly experience, but 10, 11, or even 26 dimensions, depending on the specific formulation. The extra dimensions are compactified, curled up so tightly they escape normal detection. Different vibration patterns of these fundamental strings manifest as different particles and forces. Just as various vibration patterns of a violin string produce different musical notes, different vibration patterns of cosmic strings produce electrons, photons, quarks, and all other elementary particles. But string theory doesn't merely replicate the known particles and forces. It predicts new phenomena, including gravity, arising naturally from its mathematical framework. This makes it a promising candidate for a unified theory of everything. What does string theory tell us about the origin of time? In some versions, particularly those inspired by M-theory, an extension of string theory, our universe exists as a membrane, a brane for short, floating in a higher dimensional space called the bulk. Other branes might also exist in this bulk space, like multiple sheets hanging in a larger volume. Under this scenario, the Big Bang might not represent the beginning of everything, but rather the result of a collision between branes. Imagine 2 massive sheets floating in higher dimensional space, slowly approaching each other, then colliding with unimaginable force. The energy of this collision, from our perspective confined to one brane, would appear as the Big Bang, the sudden eruption of energy that initiated our cosmic history. This ekpyrotic, from the Greek word for conflagration scenario, doesn't eliminate the question of beginnings, but it reframes it. The beginning of our universe, what we perceive as the birth of space and time, might be just one event in a larger reality that could be eternal. Time as we know it might have begun with the brane collision, but the higher dimensional reality, in which these branes exist, might have its own notion of time, perhaps without beginning or end. Imagine reality as a film reel, where time is not flowing, but every moment already exists in a sequence of frames. What we experience as the flow of time is just our consciousness moving from frame to frame, creating the illusion of temporal progression. Now imagine this film is just one among many in a vast library, each representing a different cosmic history, a different possible universe, Our Big Bang might be merely the first frame of our particular film, with other films having their own beginnings, middles, and ends, or perhaps no beginnings or ends at all. This metaphor captures something essential about string theory's approach. To cosmic origins, what appears to us as the absolute beginning of everything might be just one transition in a much larger, perhaps eternal, multiverse. Loop quantum gravity offers a different approach to the same problem. Rather than positing extra dimensions and vibrating strings, it suggests that spacetime itself has a discrete quantum structure, a kind of atomic architecture at the Planck scale, about 10 fars 35 meters. In this view, space isn't infinitely divisible, but composed of fundamental units, loops, or spin networks, that represent the quantum states of gravitational fields. Time emerges from the relationships between these fundamental spatial quanta as they evolve. One of the most striking consequences of loop quantum gravity is the elimination of the Big Bang singularity. Instead of space-time reaching a point of infinite density and curvature, loop quantum gravity suggests that when matter becomes sufficiently compressed, a repulsive quantum force prevents further contraction. This leads to the scenario of the Big Bounce, a universe that contracts to a minimum size before rebounding into expansion. Our expanding universe might have emerged from a previous contracting phase, with quantum effects preventing the formation of a true singularity at the transition point. If this is correct, our universe might be oscillating between phases of expansion and contraction, with each bounce marking not an absolute beginning, but a transition from contraction to expansion. Time, in this view, might extend infinitely into both the past and the future, with no true beginning or end, only cycles of cosmic evolution. Picture an hourglass with sand flowing from one bulb to the other. When all the sand has fallen, the hourglass is flipped, and the process begins again. Each flip represents a cosmic bounce, each grain of sand a quantum of spacetime. Time doesn't begin or end. It cycles eternally through phases of expansion and contraction. But this analogy, like all analogies for cosmic processes, has limitations. In the Big Bounce scenario, it's not merely matter that contracts and expands, but space-time itself. And the transition isn't smooth like sand flowing through an hourglass neck, but a quantum leap from contraction to expansion. A fundamental phase change in the cosmic state. Causal set theory provides yet another perspective on quantum gravity and cosmic origins. It proposes that space-time isn't fundamentally continuous, but made up of discrete elements connected by causal relationships, events that can influence other events. In this view, the fabric of reality consists of a vast network of interconnected events. Time emerges from the causal structure of these events, the relationships that determine which events can influence which other events. Space emerges from the absence of causal connections. Events that cannot directly influence each other must be separated in space. Causal set theory offers a radical reimagining of cosmic origins. Instead of a universe that begins at a specific moment, it suggests a universe that grows by the continual addition of new events. Time doesn't flow like a river. It accumulates like a growing tree, with new branches of possibility constantly emerging from the trunk of the past. Imagine the universe as a cosmic game of chess, where each move creates a new board state that builds upon the previous one. The game doesn't exist all at once. It unfolds, move by move. Similarly, in causal set theory, the universe doesn't exist all at once in a block of space-time. It grows element by element, with new events constantly being added to the cosmic fabric. This growing universe perspective transforms the question of time's beginning. Perhaps time didn't begin all at once in a singular event, but emerged gradually, through the accumulation of causal relationships, a process that might have no definite starting point, just as a growing tree has no precise moment when it becomes a tree rather than a sapling or a seed. Beyond these formal approaches to quantum gravity lies a more radical possibility. That time isn't fundamental at all, but emergent from something deeper, something timeless. This idea appears in various forms across modern theoretical physics. In the Wheeler-DeWitt equation, an attempt to apply quantum mechanics to the entire universe, time vanishes entirely. The equation describes a static universe, a wave function of the universe that encompasses all possible configurations of matter and space without any reference to time's flow. Similarly, some approaches to quantum gravity suggest that at the e-body's most fundamental level, reality consists not of things evolving in time, but of relations between entities, relations that themselves have no temporal component. Time emerges only when we zoom out, much as temperature emerges from the collective behavior of particles that individually have no temperature. These timeless approaches to physics echo ancient philosophical insights. Plato spoke of the temporal world as a moving image of eternity. Medieval theologians described God as existing in an eternal now outside of time's flow. Eastern philosophical traditions often portrayed time as illusory, a veil that obscures the timeless nature of ultimate reality. But how can timelessness give rise to time? How can the eternal become temporal? How can causality emerge from acausality? These questions push us toward one of the most profound paradoxes in modern physics, the problem of time's arrow. Why does time flow in one direction, from past to future, rather than the other? Why do we remember the past but not the future? Why do causes precede effects rather than following them? The laws of physics at the fundamental level are almost entirely time-symmetric. Run a physical process backward, and it remains a valid possibility according to most equations. Yet our experience of reality is profoundly time-asymmetric. Eggs break, but don't unbreak. Coffee cools, but doesn't spontaneously heat up. People age, but don't grow younger. This asymmetry is generally attributed to entropy, the tendency of ordered systems to become disordered over time. The second law of thermodynamics states that the total entropy of an isolated system never decreases. This provides a direction for time's flow, from lower entropy to higher entropy, from order to disorder. But why was the early universe in a state of low entropy? If the most probable state for a system is high entropy, maximum disorder, then the Big Bang represents an extraordinarily improbable state. The universe began in a highly ordered configuration and has been becoming more disordered ever since. This gives rise to the thermodynamic arrow of time that we experience, yet this merely pushes the question back further. What caused the early universe to be in such an improbable, low-entropy state? Some physicists, including Roger Penrose, have proposed that entropy should be understood in gravitational terms. While the early universe was hot and dense, which might seem like high entropy, it was extraordinarily uniform, with matter and energy distributed very evenly, which represents low gravitational entropy. As the universe evolved, gravity caused matter to clump into galaxies, stars, and planets, increasing gravitational entropy even as it created local pockets of order that eventually enabled life. In this view, the arrow of time is fundamentally connected to gravity and the expansion of the universe. But this still doesn't explain why the universe began in such a uniform state. Was it simply an extraordinarily unlikely starting condition, or does it hint at deeper principles governing cosmic origins? The inflationary model of the early universe offers one potential explanation. Cosmic inflation, an exponential expansion in the first fraction of a second after the Big Bang, would have stretched quantum fluctuations to macroscopic scales, creating the tiny temperature variations observed in the cosmic microwave background. This process could have produced a universe that appears to be in a low entropy state from our perspective. Yet inflation itself requires specific initial conditions to begin. Some versions of inflationary theory suggest that inflation is eternal, that most of the universe continues to inflate forever, with only pockets like our observable universe stopping inflation and developing into regions where conventional, physical laws apply. This eternal inflation scenario leads to a multiverse, a vast, perhaps infinite collection of bubble universes, each with potentially different physical constants and laws. Our universe would be just one bubble in this vast cosmic foam, with its particular beginning marking the transition from inflationary expansion to conventional expansion. In such a multiverse, the question of time's beginning becomes even more complex. Our local time might have begun with the formation of our bubble universe, but the multiverse itself might be eternal, with new bubble universes constantly forming in the ever-inflating background space. Imagine the multiverse as an endless ocean, with our universe just one wave rising and eventually falling back into the cosmic deep. Each wave has its beginning and end, its own local time, but the ocean itself might be eternal, with waves continually forming and dissolving without beginning or end. This oceanic metaphor captures something essential about multiverse theories. They don't eliminate the question of beginnings, but they transform it, embedding our local cosmic history within a larger, perhaps eternal, context. The beginning of our time might not be the beginning of all time, just as the formation of a wave doesn't mark the creation of the ocean. But even eternal multiverse scenarios face a deeper question. Why does anything exist at all? Why is there something rather than nothing? This is not merely a philosophical query, but a physical one. What brought the multiverse itself into existence, or caused it to exist eternally? What selected the laws or meta-laws that govern its evolution? These questions push us beyond physics into metaphysics, beyond empirical science into philosophical speculation. They remind us that while we've made remarkable progress in understanding cosmic evolution since the Big Bang, the ultimate origin, the cause of causes, the beginning of beginnings, remains shrouded in mystery. Perhaps this mystery is temporary, a gap in our current understanding that future theories will fill. Or perhaps it's more fundamental, a limit to what can be explained within the framework of physical causality. After all, any explanation of the ultimate origin would itself require a further explanation, potentially leading to an infinite regress of causes. Some philosophers and physicists suggest that this regress can be broken only by something self-explaining, something whose existence is necessary rather than contingent. This echoes traditional concepts of divinity, or the uncaused cause of medieval philosophy. Others propose that the universe might exist without explanation, as a brute fact that can't be further reduced. Still others suggest that the ultimate explanation might involve mathematical necessity, that the laws of physics are as they are because they're the only logically consistent set possible. In this view, our universe, or multiverse, exists because its non-existence would be mathematically contradictory. These approaches to cosmic origins remind us that the question of time's beginning isn't merely scientific, but also philosophical. It concerns not just what happened, but what could have happened, what had to happen, or what might exist beyond happening altogether. As we navigate these theoretical frontiers, we should remember that our theories are models, maps of reality, not reality itself. Different maps can represent the same territory in different ways, emphasizing different features, using different symbols and conventions. Similarly, different theories of quantum gravity might represent the same underlying reality in different mathematical languages, emphasizing different aspects of that reality. String theory emphasizes extended objects vibrating in higher dimensions. Loop quantum gravity emphasizes the discrete, quantum nature of spacetime itself. Causal set theory emphasizes the relational, evolutionary aspect of the cosmic network. Each offers insights that the others miss. Each struggles with challenges that the others might address more easily. Yet despite their differences, these approaches share a common implication. What we perceive as the beginning of time might not be an absolute beginning but a transition, a boundary, or an emergent property. The concept of an absolute beginning, a first moment before which nothing existed, not even time itself, grows increasingly problematic as we develop more sophisticated theories of quantum gravity. This doesn't mean we should abandon the question of time's beginning, but rather that we might need to reformulate it to ask not when did time begin, but how does time emerge from timelessness? Not what was the first moment, but what is the nature of moments themselves? Not what caused the universe, but what is the nature of causality in a quantum gravitational context? These reformulated questions might lead us toward answers that transcend our current conceptual framework, just as Einstein's theories transcended the Newtonian framework, revealing it as a useful approximation rather than a fundamental truth. To appreciate the scale of the conceptual revolution that might be required, consider how radically Einstein transformed our understanding of gravity. Newton described gravity as a force acting instantaneously across empty space, a description that worked brilliantly for most practical purposes, but ultimately proved incomplete. Einstein revealed gravity to be the curvature of space-time caused by mass and energy, not a force at all in the Newtonian sense, but the geometry of reality itself. Similarly, our current concepts of time, causality, and beginning might be approximate descriptions that work well in most contexts, but break down when applied to cosmic origins. The true nature of time might be as different from our intuitive understanding as Einstein's curved space-time was from Newton's absolute space and time. This suggests that understanding time's beginning might require not just new mathematics or better observations, but a fundamental reconceptualization of time itself. A shift in how we think about temporal concepts like before, after, beginning, and cause. Such reconceptualization is already occurring in various theoretical approaches. In eternal inflation scenarios, our local time begins with the formation of our bubble universe, but the multiverse itself has no beginning in any conventional sense. In cyclic models inspired by loop quantum gravity, our cosmic expansion emerged from a previous contraction, with no absolute beginning in either direction. In causal set theory, the universe grows by the continual addition of new elements, with no sharp division between existence and non-existence. These approaches don't merely offer different accounts of what happened at the beginning, they transform the concept of beginning itself, embedding it within larger temporal structures or revealing it as an emergent property rather than a fundamental feature of reality. But even as our theories grow more abstract and mathematical, we shouldn't lose sight of the profound mystery at the heart of the question. The beginning of time, or the emergence of time from timelessness, isn't merely a technical puzzle in theoretical physics. It touches something essential about existence itself, about the nature of possibility, about the boundary between being and non-being. When we ask how time began, we're really asking, how did anything begin? How did possibility itself come into being? How did the eternal is give rise to the flowing was and will be? These questions resonate not just with our scientific curiosity, but with our existential wonder at finding ourselves in a universe at all. This wonder connects us to countless generations of humans who have gazed at the stars and asked similar questions. The language changes, from mythic narratives to philosophical arguments to mathematical equations, but the underlying mystery persists. How did all this begin? Or has it always been? And if it has always been, what does always mean in a context? Without time? As we continue our exploration, let's hold this tension between the technical details of modern cosmology and the profound mystery they address. For in this tension lies the true wonder of the quest to understand time's beginning. A quest that engages not just our intellect, but our imagination, our philosophical insight, and our capacity for awe. The mathematical equations describing the early universe tell a story more dramatic than any myth. A cosmos emerging from quantum fluctuations, inflating exponentially, cooling and condensing into galaxies, stars, planets, and eventually life capable of contemplating its own origins. Yet, behind these equations lies a fundamental mystery that mathematics alone might never fully capture: the nature of existence itself, the enigma of why there is something rather than nothing. This brings us to another profound aspect of time's beginning: the role of the observer. In quantum mechanics, the act of observation plays a crucial role in determining physical reality. Before observation, quantum systems exist in superpositions of multiple states. Observation causes these superpositions to collapse into specific outcomes. Applied to cosmology, this raises a provocative question. What role does observation play in the emergence or existence of time? Could time in some sense require observers to experience it, to mark its passage, to distinguish past from future? The anthropic principle addresses this from one angle, noting that we could only find ourselves in a universe compatible with our existence. If time's beginning had been different, if the physical constants established in the early universe had varied slightly, we wouldn't be here to ask about it. This doesn't explain why time began as it did, but it suggests that the question itself might be constrained by the conditions necessary for observers to exist. More radically, some interpretations of quantum mechanics suggest that consciousness itself might play a role in the emergence of classical reality from quantum possibilities. If time emerges from quantum phenomena, could consciousness be implicated in the emergence of time itself? These speculations push us toward the boundaries of science into territory where physics meets philosophy of mind. Yet they remind us that time isn't just an objective dimension existing independently of observers. It's also a subjective experience, a medium of consciousness, the dimension through which we perceive and interpret reality. When we ask how time began, we're asking not just about an external cosmic process, but about the emergence of the very framework within which we experience and understand the world. We're questioning not just the origin of the universe, but the genesis of our capacity to perceive that universe temporally, to distinguish past from future, to remember what was and anticipate what will be. This suggests yet another reformulation of our central question: not just how did time begin, but how did temporal experience emerge? Not just when did the universe start, but how did the universe evolve the capacity to reflect on its own beginning? For in a profound sense, time's beginning isn't just a distant cosmic event. It's a process that continues in every moment of awareness, in every act of memory, and anticipation, in every conscious distinction between what was, what is, and what might be. Consider your own experience of time. You don't perceive time directly. You perceive change, movement, transformation. You remember the past, you anticipate the future, but you experience only the present moment. Yet this present isn't a mathematical instant. It has duration, thickness, a span within which experience unfolds. Some philosophers and neuroscientists suggest that consciousness creates a specious present, a temporal window within which events are experienced as simultaneous or present, despite occurring at slightly different physical times. This window might be around 100 milliseconds, integrating neural signals that arrive at different times into a unified experience of now. This neurological present exists within the larger psychological present of our immediate awareness, which, in turn, exists within the autobiographical time of our life narrative, which exists within historical time, cosmic time, and perhaps other temporal frameworks beyond our direct experience. These nested temporalities suggest that time isn't a single, uniform phenomenon, but a complex, multi-layered aspect of reality that manifests differently at different scales and in different contexts. Quantum time, psychological time, historical time, and cosmic time might be related but distinct aspects of a deeper temporal reality that no single framework fully captures. If this is true, then the beginning of time might not be a single event, but a multi-layered emergence, a series of transitions from timelessness to time, from simultaneity to sequence, from eternal being to temporal becoming. This perspective aligns with certain approaches to quantum gravity that suggest time emerges. Gradually, as we move from quantum scales to classical scales, from the microscopic to the macroscopic, from the fundamental to the phenomenal. In these approaches, the question isn't whether time exists or doesn't exist, began or didn't begin, but rather how temporal properties emerge under certain conditions, and at certain scales. Time might be neither absolutely real nor absolutely illusory, but rather a conditional property that emerges in specific contexts and from specific perspectives. This emergence might be analogous to how wetness emerges from collections of water molecules, which individually aren't wet, or how life emerges from particular arrangements of non-living matter, or how consciousness emerges from neural activity in the brain. In each case, the emergent property isn't present in the individual components, but arises from their collective behavior and relationships. Applied to time's beginning, this suggests that time might have emerged gradually as the universe evolved from quantum fluctuations to classical structures, from microscopic simplicity to macroscopic complexity, from undifferentiated energy to differentiated forms. The beginning of time in this view wouldn't be a sharp division between non-time and time, but a transition zone, a boundary layer, a gradual emergence of temporal properties from non-temporal or proto-temporal substrates. This evolution of time might continue even now, with new temporal modalities emerging as the universe develops new forms of organization and complexity. The temporality experienced by conscious beings might represent a higher-order emergence from more basic temporal processes, just as consciousness itself might represent a higher-order emergence from more basic cognitive processes. If this is correct, then the question of time's beginning becomes inseparable from the question of cosmic evolution generally, the process by which the universe has developed increasingly complex structures, relationships, and properties over its history. From this perspective, we might reformulate our central question once again. Not just, how did time begin? But, how has time evolved? Not just, when did temporal processes start? But, how have temporal processes developed and diversified throughout cosmic history? This evolutionary approach to time's beginning aligns with certain themes in modern complexity theory and non-equilibrium thermodynamics, which explore how ordered structures emerge spontaneously in systems far from thermodynamic equilibrium. Time's arrow, the asymmetry between past and future, might be intimately connected to this emergence of complexity, with both requiring energy flows and entropy production. The physicist Ilya Prigogine suggested that time's irreversibility isn't merely a subjective experience or a statistical effect, but a fundamental feature of complex systems evolving far from equilibrium. In his view, time's arrow emerges naturally in such systems, not as an illusion or approximation, but as an essential aspect of their dynamics. Applied to cosmology, this suggests that time's asymmetry might be intrinsically connected to the universe's evolution from simplicity to complexity, from homogeneity to heterogeneity, from uniformity to diversity. The beginning of time, in this framework, might coincide with the first emergence of complexity from uniformity, the first deviation from perfect symmetry. This perspective resonates with certain interpretations of cosmic inflation, which suggest that our observable universe emerged from a quantum fluctuation in a pre-existing inflationary field. This fluctuation broke the symmetry of the inflationary state, creating a region that eventually evolved into our cosmos. If time's asymmetry emerges from broken symmetry, then time as we experience it might have begun with this primordial symmetry, breaking, not as a creation ex nihilo, but as a transition from a more symmetric, less temporally structured state to a less symmetric, more temporally structured state. This approach transforms the problem of time's absolute beginning into the more tractable problem of phase transitions in physical systems. Transitions like water freezing into ice, or magnetic materials becoming magnetized below certain temperatures, or superconductors developing zero electrical resistance when sufficiently cooled. In each of these phase transitions, the system develops new properties not present in its previous state. Similarly, cosmic phase transitions might have generated temporal properties not present in earlier states, creating what we experience as the flow of time from an initially timeless or proto-temporal condition. But this still leaves a deeper question. What caused the initial symmetry to break? What triggered the phase transition that gave rise to time as we know it? What selected this particular symmetry, breaking from all possible symmetry breakings? Here we confront again the limits of causal explanation within a temporal framework. Asking what caused time to begin presupposes temporality in the explanation of temporality itself, potentially leading to circular reasoning or infinite regress. Some approaches to this dilemma suggest that the ultimate explanation might be a causal, not a temporal sequence of cause and effect, but a logical or mathematical necessity that exists outside the temporal framework altogether. For instance, certain interpretations of quantum cosmology suggest that the universe emerges from nothing through quantum tunneling, a process in which a system passes through a classically forbidden region to transition between quantum states. This tunneling wouldn't be caused by anything in the conventional sense. It would be in a causal transition governed by quantum probability. Similarly, mathematical approaches to cosmology sometimes envision the universe as a mathematical structure that exists necessarily, not in the sense of being caused to exist, but in the sense of being a logical inevitability, a structure that couldn't not exist without creating mathematical contradiction. These causal explanations don't eliminate the mystery of time's beginning, but they transform it, suggesting that our intuitive notions of causality might be inadequate when applied to the ultimate origin. The beginning of time might require not a prior cause, but a different kind of explanation altogether, one based on necessity, probability, or mathematical elegance, rather than temporal sequence. This approach resonates with certain philosophical traditions that distinguish between temporal causality, one event causing another in time, and ontological dependence, one reality deriving its existence from another without temporal sequence. The universe's existence might depend ontologically on mathematical principles or quantum laws without being temporally caused by them. Yet even these causal explanations face a fundamental challenge. Why these laws or principles rather than others? What selects the particular mathematical structures or quantum fields that give rise to our universe? What determines the rules that govern reality's emergence? Some theorists propose a principle of fecundity. Perhaps all mathematically possible structures exist, with our universe being just one among countless realities, each governed by different equations, different logics, different relationships. This mathematical multiverse would include every consistent set of laws, with our particular reality distinguished only by containing observers like us. Others suggest a principle of simplicity or elegance. Perhaps the laws governing reality are those that can be expressed most economically, with the fewest arbitrary constants or assumptions. This Occam's razor approach to cosmic origins suggests that the universe exists as it does, because any other form would require more complexity, more arbitrary parameters, more unexplained elements. Still others propose varying forms of the anthropic principle. The laws governing reality must be those that allow observers to evolve, since any other laws would leave no one to ask about them. This doesn't explain why these particular laws exist, but it explains why we find ourselves in a universe governed by them rather than by other possible laws incompatible with our existence. These approaches to the ultimate explanation remind us that the question of time's beginning extends beyond physics into metaphysics, beyond empirical science into logical and philosophical inquiry. It concerns not just what we can observe or calculate, but what must be, what could be, what selection principles might operate at the most fundamental level of reality. As we contemplate these possibilities, we should remember that our reasoning itself occurs within time. Our logic, our language, our very thought processes are temporal, unfolding in sequence, building conclusions from premises, moving from uncertainty toward clarity, or sometimes the reverse. We attempt to understand time's beginning using cognitive tools that themselves presuppose temporality. This creates a profound challenge. We're trying to understand the origin of time from within time, to explain the genesis of causality using causal reasoning, to comprehend the beginning of beginnings using concepts that presuppose beginning. It's like trying to see your own eyes without using a mirror, or lift yourself by pulling on your own bootstraps. The very framework we use to understand reality might be inadequate for understanding the origin of that framework itself. This limitation doesn't mean we should abandon the quest to understand time's beginning, but it suggests we should approach this quest with intellectual humility, recognizing that our concepts, our language, our logic, and our mathematics, powerful as they are, might require fundamental revision when applied to the ultimate questions of existence. This humility isn't a retreat into mysticism or a surrender to ignorance. Rather, it's an openness to conceptual revolution, a willingness to revise our most basic assumptions, a recognition that our current understanding, impressive as it is, remains provisional, approximate, and potentially radically incomplete. Just as Newtonian physics gave way to relativity and classical physics to quantum mechanics, our current frameworks for understanding time and its beginning might eventually be superseded by more comprehensive, more subtle, more powerful approaches that we can barely glimpse from our present vantage point. This openness to future revolution reminds us that the quest to understand time's beginning isn't a linear journey toward a fixed destination, but a spiraling exploration that continually revises both its path and its goal. Each new insight transforms not just our answers, but our questions. Each discovery reveals not just new knowledge, but new ignorance. In this sense, the quest to understand time's beginning exemplifies science at its most profound, not as a body of settled facts, but as a method for exploring the unknown, a discipline of wonder that uses our ignorance as a guide to discovery, a tradition that values questions as much as answers, and revision as much as certainty. And so we continue our exploration, guided by the interplay of theory and observation, mathematics, and intuition, physics and philosophy, always reaching toward deeper understanding while remaining open to the possibility that the deepest truth about time's beginning might transcend our current conceptual categories altogether. For in confronting the mystery of time's origin, we confront the limits not just of our knowledge, but of knowledge itself, at least knowledge as we currently conceive it. We approach a boundary where empirical science meets metaphysical inquiry, where physical causation meets logical necessity, where temporal sequence meets eternal truth. And perhaps at this boundary, this horizon of understanding, we discover something profound not just about the universe, but about ourselves as knowers, about the scope and limits of human comprehension, about the relationship between our minds and the cosmos they seek to understand, about the place of consciousness in the vast sweep of cosmic evolution. For we are not merely observing cosmic history from the outside, we are participants in that history, products of the same processes we seek to understand. The atoms in our bodies were forged in stellar furnaces that no longer exist. The patterns of our thoughts emerge from neural structures shaped by billions of years of evolution. In a very real sense, the universe has evolved the capacity to contemplate its own origins. Through consciousness, through your consciousness in this moment, the universe achieves a kind of self-awareness, an ability to reflect on its own origin and evolution. This remarkable capacity for self-reflection suggests a different way of thinking about the question of time's beginning. Perhaps the most significant aspect of cosmic history isn't the first moment, but rather the emergence of consciousness capable of contemplating that first moment. Perhaps the universe achieves something essential not at its temporal origin, but through the eventual evolution of minds that can reconstruct that origin through science, art, philosophy, and wonder. From this perspective, the question, "How did time begin?" is less about pinpointing an initial moment and more about understanding the entire arc of cosmic evolution that leads from simple physical processes to conscious contemplation. It's about recognizing that time itself, the dimension along which this evolution occurs, might be more complex, more mysterious, and more profound than our everyday experience suggests. As we continue our exploration, let's hold this tension between our temporal nature and our capacity to contemplate timelessness, between our existence within the cosmos and our ability to conceptualize the cosmos as a whole. For it is precisely this tension that drives scientific progress, philosophical insight, and the deepest forms of human wonder. Now let's turn our attention to another profound aspect of time's beginning, the role of information. Modern physics increasingly recognizes information as a fundamental aspect of reality, perhaps even more fundamental than matter or energy. This perspective has profound implications for how we understand cosmic origins. In the framework of quantum mechanics, physical systems are described by wave functions that encode all possible states of the system along with their probabilities. These wave functions evolve according to precise mathematical rules until measurement causes them to collapse into specific observed states. This process, the transition from quantum possibilities to classical actualities, can be viewed as the creation of information. Before measurement, the system exists in a superposition of multiple states. After measurement, it exists in a single definite state. Information has been created where previously there was only probability. Applied to cosmology, this suggests that the beginning of time might be understood as the first creation of information, the first transition from quantum indeterminacy to classical determinacy, from possibility to actuality, from potential to manifestation. In this view, time doesn't flow like a river. It accumulates like a growing database, with each moment adding new information to the cosmic record. The beginning of time would mark the first entry in this database, the first instance of definite information emerging from quantum indeterminacy. But this raises a new question. What constitutes measurement or observation in the context of the early universe, before any conscious observers existed? What causes quantum superpositions to resolve into definite states in the absence of consciousness? Various interpretations of quantum mechanics offer different answers. The decoherence interpretation suggests that interaction with the broader environment causes quantum systems to rapidly evolve into states that behave classically. No conscious observer is required. The complexity of environmental interactions effectively performs the measurement. Applied to cosmology, this suggests that time might have begun when the primordial quantum field first developed sufficient internal complexity for decoherence to occur, when distinct systems and environments first differentiated within the cosmic whole, allowing information to be recorded in stable forms. The universe, in this view, didn't begin with a bang, but with a bit. The first definite piece of information, the first irreversible distinction between what is and what could have been. This informational perspective aligns with certain approaches to quantum gravity that describe space-time itself as emergent from more fundamental quantum information. In these frameworks, space and time aren't primitive realities, but rather arise from the relationships between quantum bits of information, much as the solid surface of a desk emerges from relationships between atoms that are mostly empty space. If space-time emerges from quantum information, then the beginning of time might coincide with the emergence of certain informational patterns or relationships from a more fundamental, timeless quantum reality. Time would begin not as a dimension that suddenly comes into existence, but as a pattern that gradually crystallizes from timeless quantum potentiality. This emergence might be analogous to how temperature emerges from the collective motion of particles, or how pressure emerges from their collective impacts. In each case, the emergent property, temperature, pressure, time, isn't present in the individual components, but arises from their collective behavior and relationships. Applied to time's beginning, this suggests that time might have emerged gradually, as quantum information developed increasingly complex patterns, relationships, and correlations. The beginning of time, in this view, wouldn't be a sharp division between non-time and time, but a transition zone, a boundary layer, a gradual emergence of temporal properties from non-temporal quantum information. This informational approach to time's beginning resonates with certain themes in information theory and thermodynamics, particularly the connection between entropy, information, and the arrow of time. In classical thermodynamics, entropy measures the disorder or randomness of a system, the number of possible microscopic states that correspond to its observable macroscopic state. The second law of thermodynamics states that the entropy of an isolated system never decreases over time, providing a direction for time's flow. In information theory, entropy measures uncertainty or potential information, the number of bits needed to specify a particular state from among all possible states. These two concepts of entropy, thermodynamic and informational, are intimately connected, suggesting a profound relationship between information, thermodynamics, and the direction of time. This relationship appears in various physical contexts, from Maxwell's demon thought experiment, which explores the connection between information and thermodynamic work, to Landauer's principle, which establishes the minimum energy required to erase a bit of information, to black hole thermodynamics, which relates the entropy of a black hole to the area of its event horizon. Applied to cosmology, this suggests that time's arrow, the asymmetry between past and future, might be fundamentally connected to the flow of information. The past is determinate because information about it has been recorded in the present. The future is indeterminate because information about it hasn't yet been created. In this framework, the beginning of time might coincide with the first creation of irreversible information, the first instance where a quantum possibility became a classical actuality in a way that left an indelible mark on the cosmic record. This informational perspective transforms the question of time's absolute beginning into questions about the nature of information itself. Can information be created or destroyed? Is there a minimum amount of information necessary for temporal processes to exist? Can information exist without time, or time without information? These questions push us toward the frontier of theoretical physics, where concepts like quantum information, entanglement, and decoherence offer new ways of thinking about reality's fundamental nature. They suggest that understanding time's beginning might require understanding not just the physics of matter and energy, but the physics of information itself. Yet even as we explore these theoretical frontiers, we should remember that our theories are models, maps of reality, not reality itself. The territory they represent might be stranger, more complex, more fundamentally mysterious than any of our current maps suggest. Consider the limitations inherent in our approach. We're temporal beings using temporal concepts to understand the origin of temporality. We're embedded in a universe we're trying to conceptualize as a whole. We're products of the same processes we seek to explain. These limitations don't invalidate our quest, but they remind us of its profound challenges and inevitable incompleteness. Moreover, our exploration occurs within a particular historical and cultural context, a context shaped by specific philosophical traditions, scientific methodologies, technological capabilities, and conceptual frameworks. Different cultures, different historical periods, or different forms of consciousness might approach the question of time's beginning in ways we can barely imagine. This contextual nature of inquiry doesn't reduce it to mere cultural relativism or subjective opinion. The universe exists independently of our theories about it, and some theories capture its patterns more accurately than others. But it does remind us that our particular approach to cosmic origins, with its emphasis on mathematical physics, empirical observation, and logical analysis, represents just one path toward understanding among many possibilities. Other approaches, mystical, artistic, contemplative, or as yet unimagined, might access aspects of temporal reality that our scientific approach misses or cannot articulate. The beginning of time might be not merely a physical event to be explained, but a mystery to be encountered, a paradox to be lived, a horizon of thought to be approached but never fully reached. This plurality of approaches reminds us that the question of time's beginning engages not just our intellect, but our entire being. Our sensory experience, our emotional responses, our aesthetic sensibilities, our capacity for wonder, our awareness of our own mortality, our yearning for the eternal. It's a question that resonates across the full spectrum of human inquiry and experience, from the most abstract mathematics to the most concrete lived reality. And perhaps this full-spectrum resonance offers a clue about the nature of time itself, not merely as an external dimension in which events occur, but as an aspect of consciousness, a medium of experience, a framework through which reality manifests to awareness. For time as we experience it isn't just objective duration, it's also subjective. Presence, the quality of now that characterizes each moment of awareness. It's not just the ticking of a cosmic clock, but the unfolding of experience itself, the dimension along which sensation, perception, emotion, thought, and memory flow. This experiential aspect of time reminds us that when we ask about time's beginning, We're asking not just about an external cosmic process, but about the genesis of our own temporality, the emergence of the framework within which our consciousness operates, the birth of the medium in which our experience unfolds. And this brings us full circle to the profound mystery at the heart of our question: how did time begin? How did the eternal give rise to the temporal? How did being become becoming? How did now start to flow? These questions may never receive final answers, at least not within our current conceptual frameworks. But in contemplating them, we participate in one of humanity's most profound activities, wondering about our origins, questioning our existence, seeking to understand not just what is, but how it came to be and what it might mean. In this contemplation, we exercise a capacity that might itself represent one of the universe's most remarkable achievements: the ability to reflect on its own existence, to question its own origin, to marvel at the very fact that it exists at all rather than not. Through your consciousness in this moment, through your engagement with these ideas, these questions, these cosmic mysteries, the universe achieves a kind of self-awareness, a capacity to wonder about its own beginning, to puzzle over its own temporal nature, to contemplate timelessness from within time. This capacity for self-reflection, this ability to question our own origins, this wonder at existence itself, these might be not merely psychological curiosities, but essential aspects of cosmic evolution, as fundamental to the universe's nature as gravity, electromagnetism, or the nuclear forces. For, in contemplating time's beginning, we don't merely observe cosmic history from the outside. We participate in its ongoing unfolding, contributing to the universe's growing complexity, its expanding web of relationships, its deepening self-awareness. The beginning of time, in this sense, isn't just a distant cosmic event, but a process that continues in each moment of conscious awareness, a beginning that begins again with each new insight, each fresh question, each deepening of wonder at the mystery of existence. And perhaps this ongoing beginning, this perpetual renewal of temporal awareness, offers the most profound answer to our question. Time begins not once and for all in a singular cosmic event, but continually, moment by moment, in the ever-fresh emergence of now, in the eternally renewed presence of being, in the perpetual genesis of awareness itself. This perspective doesn't invalidate the scientific quest to understand cosmic origins through observation, experimentation, and mathematical theory, but it reminds us that this quest itself occurs within time, within consciousness, within the very reality it seeks to explain. To truly understand time's beginning, we might need to recognize ourselves not merely as observers of cosmic history, but as participants in its ongoing creation, not merely as products of temporal processes, but as contributors to time's continuing emergence, as agents in the universe's evolving self-awareness. This recognition transforms the question of time's beginning from a purely objective inquiry about external events to a participatory exploration in which the questioner is implicated in the question, the seeker involved in what is sought, the knower entangled with what is known. In this participatory mode of inquiry, understanding time's beginning becomes not merely a matter of finding the right theory or gathering the right data, but of deepening our awareness, expanding our consciousness, transforming our relationship with temporality itself. This doesn't mean abandoning scientific rigor or empirical observation, but it suggests that these approaches might be complemented by other modes of engagement, contemplative, experiential, intuitive, that access aspects of temporal reality that conceptual thought alone might miss. As we navigate these diverse approaches to time's beginning, let's remain open to the possibility that our question might ultimately transform us more than we transform it. That in seeking to understand time's origin, we might discover not just new facts about cosmic history, but new dimensions of our own consciousness, new aspects of our relationship with reality, new modes of temporal being. For the question of time's beginning isn't merely intellectual, it's existential. It concerns not just the universe's history, but our place within that history, our relationship with temporality, our status as beings who exist in time yet can contemplate timelessness, who are products of cosmic evolution, yet participants in its ongoing unfolding. In contemplating how time began, we confront not just an abstract puzzle in theoretical physics, but a mystery that touches the core of our being, our awareness of our own mortality, our experience of change and impermanence, our capacity for memory and anticipation, our yearning for the eternal amid the flux of temporal existence. And perhaps in this existential dimension, this personal resonance, this subjective significance, we discover something essential about time itself, not merely as an external dimension in which events occur, but as an aspect of consciousness, a quality of experience, a framework through which reality manifests to awareness. Time, in this view, isn't just a parameter in equations or a coordinate in space-time diagrams. It's the medium of our experience, the dimension of our being, the river in which our consciousness flows. Its beginning isn't just a cosmic event, but a genesis of awareness, a birth of presence, an emergence of now. This perspective doesn't resolve the scientific questions about cosmic origins, quantum gravity, or the nature of the Big Bang. But it reminds us that these questions arise within a broader context of human wonder, existential inquiry, and spiritual aspiration, a context in which the beginning of time concerns not just what happened then, but what is happening now, in this moment of awareness, this instant of presence, this eternal now. In this eternal now, this ever-present moment of awareness, we might glimpse something profound about time's nature, not merely as a dimension stretching from past to future, but as a quality of consciousness, an aspect of being, a manifestation of the eternal in the temporal, the infinite in the finite, the absolute in the relative. And in this glimpse, we might discover not a final answer to our question, but a deepening of the question itself, a recognition that time's beginning concerns not just cosmic history, but cosmic meaning, not just physical processes, but metaphysical significance, not just how the universe began, but why it exists at all, and what our place might be within its vast unfolding. This deepening doesn't end our inquiry. It enriches it, adding layers of significance, dimensions of meaning, perspectives of value that complement the scientific account without contradicting its empirical findings or mathematical formulations. For the question of time's beginning, like all ultimate questions, addresses not just the nature of reality, but our relationship with that reality, not just what exists, but how we exist within it, how we perceive it, how we make sense of it, how we find meaning in it. And in this relationship, this engagement, this participation, we might discover something essential about both time and ourselves, about temporality as a dimension of consciousness, about consciousness as an aspect of cosmic evolution, about the universe not merely as an external object to be observed, but as a reality in which we're embedded, a process in which we participate, a story in which we're both characters and co-authors. This participatory perspective transforms the question of time's beginning from a purely objective inquiry to a dialogue between observer and observed, knower and known, consciousness and cosmos, a dialogue in which each informs and transforms the other, in which understanding emerges not through detached observation, but through engaged participation. In this dialogue, the scientific quest to understand cosmic origins through observation, experimentation, and mathematical theory remains essential. But it's complemented by other modes of engagement, philosophical, artistic, contemplative, that access aspects of temporal reality that science alone might miss. Together, these diverse approaches offer a more complete, more nuanced, more multidimensional understanding of time's beginning, an understanding that honors both the objective patterns discerned by science and the subjective significance experienced in consciousness. This integral understanding recognizes that time's beginning isn't merely a physical event to be explained, but a mystery to be encountered, a paradox to be lived, a horizon of thought to be approached but never fully reached, a question that engages not just our intellect, but our entire being, from the most abstract cognition to the most concrete embodied experience. And in this full-spectrum engagement, we might discover not a final answer, but a deepening wonder, an expanding awareness, a growing recognition of the profound mystery at the heart of existence. The mystery not just of how time began, but of why there is something rather than nothing, why being rather than non-being, why consciousness rather than mere mechanism. This deepening wonder, this expanding awareness, this growing recognition doesn't conclude our exploration, but enriches it, transforming it from a mere search for information to a journey of transformation, from an accumulation of knowledge to an evolution of consciousness, from a quest for facts to a pilgrimage of meaning. For in contemplating time's beginning, we engage not just with cosmic history, but with cosmic significance, with questions of origin, destiny, purpose, value that transcend the purely physical and enter the realm of the metaphysical, the existential, the spiritual. These questions don't contradict the scientific account of cosmic origins. They complement it, adding dimensions of meaning, perspectives of value, aspects of significance that science itself, by its methodological constraints, cannot directly address. For science tells us what happened and how it happened, but not why it happened or what it means. It describes the patterns, processes, and relationships that characterize reality, but not their ultimate source, purpose, or significance. It reveals the universe's structure and evolution, but not its meaning or value. These limitations don't diminish science's remarkable achievements or its essential role in understanding reality, but they remind us that science operates within a particular domain of inquiry, using specific methods to answer certain types of questions. Questions about patterns, processes, and relationships that can be observed, measured, and mathematically modeled. Other domains of inquiry, philosophical, aesthetic, contemplative, spiritual, address different types of questions using different methods, accessing aspects of reality that scientific methods, by their nature, cannot directly engage. The question of time's beginning spans these diverse domains, involving both scientific inquiry into cosmic origins and metaphysical reflection on ultimate causes, both mathematical modeling of physical processes and existential contemplation of meaning and purpose. This multidimensional nature of the question invites an integral approach, one that integrates scientific knowledge, philosophical insight, aesthetic sensitivity, and contemplative awareness into a more complete, more nuanced, more multifaceted understanding of time's beginning than any single perspective could offer alone. Such an integral approach doesn't blur the distinctions between different domains of inquiry or ignore the specific methodologies appropriate to each, but it recognizes that reality itself transcends our conceptual divisions, that the universe is simultaneously physical, biological, psychological, social, cultural, and spiritual, a multidimensional whole that manifests differently at different levels and from different perspectives. Time's beginning, in this integral view, isn't just a physical event, but a multidimensional emergence, a genesis of not just physical time, but biological time, psychological time, historical time, cosmic time, each with its own patterns, rhythms, and significance. This multidimensional emergence unfolds across scales, from the quantum fluctuations of the early universe to the circadian rhythms of living organisms, from the psychological experience of duration to the cultural construction of historical narrative, from the evolutionary time of biological development to the cosmic time of universal expansion. At each scale, in each domain, temporality manifests differently, with unique patterns, processes, and properties that can't be reduced to or derived from the others. Yet all are aspects of a single reality, facets of a unified cosmos, dimensions of an integrated whole. Understanding time's beginning, then, requires not just explaining the physics of the Big Bang or the mathematics of quantum gravity, but comprehending how temporality emerges and evolves across these diverse scales and domains, how physical time gives rise to biological rhythms, how biological rhythms enable psychological experience, how psychological experience constructs cultural narratives, how cultural narratives shape historical understanding. This integral perspective doesn't replace the scientific quest to understand cosmic origins through observation, experimentation, and mathematical theory, but it places that quest within a broader context of human inquiry, a context that includes philosophical reflection, artistic expression, contemplative practice, and spiritual aspiration. Within this broader context, the question of time's beginning becomes not just a puzzle to be solved, but a mystery to be lived. A question that engages not just our intellect, but our entire being, from the most abstract cognition to the most concrete embodied experience. And in this full-spectrum engagement, we might discover not a final answer, but a deepening wonder, an expanding awareness, a growing recognition of the profound mystery at the heart of existence, the mystery not just of how time began, but of why there is something rather than nothing, why being rather than non-being, why consciousness rather than mere mechanism. This deepening wonder, this expanding awareness, this growing recognition doesn't conclude our exploration, but enriches it, transforming it from a mere search for information to a journey of transformation, from an accumulation of knowledge to an evolution of consciousness. For in contemplating time's beginning, we engage not just with cosmic history, but with cosmic meaning, with questions of origin, destiny, purpose, value that transcend the purely physical and enter the realm of the metaphysical, the existential, the spiritual. These questions don't contradict the scientific account of cosmic origins. They complement it, adding dimensions of meaning, perspectives of value, aspects of significance that science itself, by its methodological constraints, cannot directly address. For science tells us what happened and how it happened, but not why it happened or what it means. It describes the patterns, processes, and relationships that characterize reality, but not their ultimate source, purpose, or significance. It reveals the universe's structure and evolution, but not its meaning or value. As we conclude this exploration of the scientific theories surrounding time's beginning, let's hold in mind both the remarkable achievements of modern cosmology and the profound mysteries that remain. Both the detailed scientific account of what happened after the Big Bang and the philosophical questions about what might have existed, before or beyond it, both the mathematical precision of our best physical theories and the conceptual revolutions they might yet undergo. For in this tension between knowing and not knowing, Between the clarity of established science and the mystery of ultimate origins, we encounter the frontier of human understanding, a frontier that invites not just further research, but deeper wonder, not just more precise measurements, but more profound questions, not just expanded knowledge, but evolved consciousness. And perhaps this is the universe's greatest achievement, not just that it exists, but that it has evolved beings capable of contemplating its existence. Not just that it began, but that it contains consciousness that can question its beginning. Not just that it unfolds in time, but that it encompasses awareness that can reflect on time's nature. In this reflection, this contemplation, this questioning, the universe achieves a kind of self-awareness, a capacity to wonder about its own origin, to puzzle over its own temporal nature, to contemplate timelessness from within time. And in your engagement with these ideas, these questions, these cosmic mysteries, you participate in this universal self-reflection, this cosmic self-awareness, this awakening of the universe to its own existence and evolution. For you are not separate from the cosmos. You are its current expression, its present manifestation, its ongoing evolution. Through your consciousness, the universe questions its beginning. Through your awareness, time reflects on its own nature. Through your wonder, existence marvels at itself. This participation, this engagement, this co-evolution of consciousness and cosmos represents not the end of our exploration, but its true beginning. Not a conclusion, but an invitation to deeper inquiry, broader perspective, more profound awareness of the mystery of time and its beginning. For the question of how time began isn't merely about the past, it's about the present and the future, about how we exist now in relation to cosmic temporality, about how consciousness might evolve in its understanding of time, about how our awareness of cosmic origins might transform our sense of cosmic destiny. In this sense, the exploration of time's beginning isn't just a scientific inquiry, but a spiritual quest, a journey not just of discovery, but of awakening, not just of knowing, but of being, not just of information, but of transformation. And on this journey, this quest, this pilgrimage toward understanding, we might discover not just facts about cosmic history, but insights about cosmic meaning, not just knowledge about how the universe began, but wisdom about why it exists and what our place might be within its vast unfolding. For in contemplating time's beginning, we contemplate our own origin as temporal beings, our own nature as conscious entities, our own significance as participants in cosmic evolution. And in this contemplation, this reflection, this deepening awareness, we might glimpse not just how time began, but how consciousness evolves, how meaning emerges, how value manifests within the vast sweep of cosmic temporality. This glimpse doesn't end our quest, but deepens it, enriches it, transforms it from a mere search for information to a journey of awakening, from an accumulation of knowledge to an evolution of consciousness, from a question about what happened then to a revelation about what is happening now, in this moment of awareness, this instant of presence, this eternal now. Now we venture deeper into the paradoxes that lie at the heart of time's beginning, the unresolvable contradictions, the conceptual dead ends, the questions that seem to dissolve the very framework within which they're asked. For it is in these paradoxes, these apparent impossibilities, that we might find the most profound insights into the nature of time and its origin. Let's begin with what philosophers call the first cause paradox, a dilemma that has haunted human thinking since antiquity. If everything that exists must have a cause, then what caused the universe? And if the universe had a cause, what caused that cause? the question leads to an infinite regress, a never-ending chain of causes stretching backward through time without beginning. To escape this regress, we might posit an uncaused first cause, something that exists necessarily rather than contingently, something that doesn't require explanation because its non-existence would be impossible. Traditional theology identified this uncaused cause with God, the necessary being who exists outside of time and brings the temporal order into existence. But this solution merely transforms the paradox rather than resolving it. For if the first cause exists outside of time, how can it cause anything within time? Causation itself is a temporal concept, involving a cause that precedes its effect. To speak of a timeless entity causing the universe, and with it, time itself, stretches the concept of causation beyond its meaningful application. Yet the alternative seems equally problematic. If time has always existed, extending infinitely into the past without beginning, then the present moment could never have arrived. For to reach the present from an infinitely distant past would require crossing an infinite temporal distance, a journey that, by definition, cannot be completed. This dilemma, either a beginning that seems to require a cause outside time, or an eternal past that seems to make the present impossible, reveals the profound challenges in applying our temporal concepts to ultimate origins. The very framework within which we formulate the question might be inadequate for the reality it seeks to describe. Modern cosmology doesn't eliminate this dilemma. It transforms it. The Big Bang Theory doesn't posit a creation ex nihilo, a beginning from absolute nothingness. Rather, it describes the expansion of the universe from an extremely hot, dense state. The initial singularity represents not the beginning of existence, but the limit of our physical theories, the point where general relativity breaks down and quantum effects become crucial. Various approaches to quantum cosmology offer scenarios where the universe emerges from quantum fluctuations in a pre-existing state, or tunnels from one configuration to another, or bounces from a previous contracting phase. These scenarios don't eliminate the question of ultimate origins, but they shift it from classical causation to quantum processes that transcend simple before and after relationships. Yet even these quantum approaches face their own paradoxes. If the universe emerged from quantum fluctuations, what was the quantum field that fluctuated? If it tunneled from one state to another, what defined those states? If it bounced from a previous phase, what initiated that phase? At each level of explanation, the question of origins resurfaces in a new form, suggesting that our very concept of beginning might be inadequate when applied to the universe as a whole. This inadequacy becomes even more apparent when we confront the paradox of ex nihilo creation, the idea that the universe arose from absolutely nothing. Philosophers since ancient times have argued that from nothing, nothing comes. If absolute nothingness once prevailed, what could have disturbed this void to produce existence? The principle of sufficient reason suggests that there must be some explanation for why there is something rather than nothing, yet the very concept of nothing precludes any such explanation. Some cosmologists, like Lawrence Krauss, have argued that the universe can indeed emerge from nothing, but their nothing is not absolute nothingness. It's a quantum vacuum, a state of minimum energy that contains the potential for particle creation through quantum fluctuations. This vacuum exists within a framework of physical laws that themselves require explanation. True nothingness would contain no quantum fields, no physical laws, no potentialities, nothing whatsoever that could give rise to existence. The philosopher Martin Heidegger framed the ultimate question as, why is there something rather than nothing? This question may have no satisfactory answer within our current conceptual framework, suggesting that there might be something fundamentally mysterious about existence itself, something that transcends causal explanation. This mystery deepens when we consider the paradox of time's direction. Why does time flow from past to future, but never the reverse? The fundamental laws of physics don't distinguish between past and future. They work equally well in either direction. Run a physical process backward, and you get another valid physical process, at least according to the basic equations. Yet our experience of reality is profoundly time asymmetric. We remember the past, not the future. Causes precede effects. Eggs break, but don't unbreak. Hot coffee cools to room temperature, but room temperature coffee doesn't spontaneously heat up. This asymmetry is generally attributed to entropy, the tendency of ordered systems to become disordered over time. The second law of thermodynamics states that in an isolated system, entropy never decreases. This provides a direction for time's flow, from lower entropy to higher entropy, from order to disorder. But why was the early universe in a state of low entropy? If high entropy, maximum disorder, is the most natural, most probable state for a system, then the Big Bang represents an extraordinarily improbable initial condition. The universe began in a highly ordered configuration and has been becoming more disordered ever since. This gives rise to the thermodynamic arrow of time that we experience. The cosmologist Roger Penrose has estimated that the probability of the universe beginning in a low entropy state by random chance is on the order of 1 in 10 123, a number so vast that it couldn't be written out even if every particle in the universe were used as a digit. This suggests that either our universe represents an inconceivably improbable fluke, or there's some deeper principle at work that required or selected this initial condition. But what could that principle be? What could explain the extraordinarily special initial state of the universe? And why does entropy increase toward the future, but not toward the past? Some physicists have proposed that entropy increases in both temporal directions away from the Big Bang, creating two opposite arrows of time. Others suggest that the entropy of the universe as a whole doesn't change, but our observable universe represents a fluctuation from equilibrium that's gradually returning to a more probable state. Still others propose that gravitational entropy, rather than thermodynamic entropy, provides the key to understanding cosmic time asymmetry. These approaches offer valuable insights, but none has yet provided a complete, widely accepted explanation for time's arrow. The origin of temporal asymmetry remains one of the most profound unsolved problems in modern physics, a problem intimately connected to the question of how time began. This connection becomes even more apparent when we consider the paradox of quantum measurement. In quantum mechanics, physical systems exist in superpositions of multiple states until measured, at which point they collapse into definite states. This process seems inherently time asymmetric. Before measurement, multiple possibilities. After measurement, a single actuality. But what constitutes a measurement? And why does measurement cause quantum systems to collapse into definite states? Various interpretations of quantum mechanics offer different answers, from the role of conscious observation, the Copenhagen interpretation, to the splitting of reality into multiple branches, the many worlds interpretation, to the effect of environmental decoherence, the consistent histories approach. Each interpretation has its strengths and challenges, but none provides a universally accepted explanation for the apparent time asymmetry of quantum measurement. And when applied to cosmology, these interpretations raise profound questions about the role of observation, consciousness, and information in the emergence of classical reality from quantum potentiality. If quantum measurement plays a role in the emergence of classical spacetime from quantum fluctuations, then the beginning of time might be intimately connected to the first instances of quantum decoherence, or measurement, in the early universe. Time's arrow and time's beginning might be aspects of the same fundamental process. The emergence of classical determinacy from quantum indeterminacy. This connection points toward another profound paradox: the observer effect in quantum cosmology. In standard quantum mechanics, an observer measures a system, causing its wave function to collapse into a definite state. But in quantum cosmology, the system is the entire universe. What plays the role of observer for the universe as a whole? What or who stands outside the universal wave function to cause its collapse? Some approaches to this paradox suggest that the universe might serve as its own observer, with different parts effectively measuring other parts through their interactions. Others propose that consciousness plays a special role, with the emergence of conscious observation somehow retroactively determining the classical history of the cosmos. Still others argue that the universal wave function never actually collapses. It merely appears to do so, from our perspective, within one branch of a vast multiversal reality. Each of these approaches has profound implications for how we understand time's beginning. If the universe serves as its own observer, then classical time might have emerged gradually as the cosmos developed sufficient internal complexity for effective self-measurement. If consciousness plays a special role, then the beginning of time might be connected to the potential for consciousness. Until now, we've explored time's beginning as an abstract scientific puzzle, a fascinating intellectual challenge to be solved with equations, theories, and observations. But the implications of what we've discovered reach far beyond academic curiosity. They strike at the very foundation of how you understand yourself and your place in the cosmos. Look at your hands for a moment. These collections of atoms, these assemblages of particles and energy, have existed since the beginning of time. Since that first moment we've been struggling to comprehend. The matter that forms your body was forged in stellar furnaces, scattered by supernovae, gathered into planets, and eventually assembled into the precise configuration that is you. You are not separate from cosmic history. You are its current, embodiment, its living continuation, its conscious expression. And if time itself is in question, then what does that mean for you? If time is not fundamental but emergent, if the flow from past to future is in some sense illusory, then everything you've ever done, every choice you've ever made, every moment you've ever experienced, might have already happened infinite times before, or might be happening simultaneously across branching realities, or might exist eternally in a timeless block universe where before and after are merely directions, like left and right, in a four-dimensional reality. Feel the weight of that possibility for a moment. The distinction between past, present, and future, the very structure of your conscious experience, might be a kind of illusion, a perspective effect, a limitation of your temporal viewpoint rather than a fundamental feature of reality. You live your life as a story unfolding moment by moment, but physics suggests the universe might exist more like a completed novel. All moments existing simultaneously, the beginning and end already written, the narrative complete though experienced sequentially by the characters within it. In such a universe, what happens to free will, to moral responsibility, to the meaning of choice and consequence? If the future already exists in some sense, are your decisions merely discoveries of what was already determined? Are you a character, acting out a predetermined role, or an author writing the story as you go? These aren't merely philosophical musings. They strike at the heart of how you experience your existence, how you make sense of your life, how you find meaning in a universe that might transcend the very framework within which meaning traditionally operates, and the implications grow more profound, more unsettling, more vertiginous as we consider other possibilities revealed by our exploration. If the multiverse hypothesis is correct, if our universe is just one bubble in an infinite cosmic foam, or one branch in an endlessly splitting quantum tree, then, somewhere, in some version of reality, every possibility that could have happened to you has happened. Every decision you didn't make, every path you didn't take, every potential version of you exists in some branch of this vast multiversal structure. Somewhere, there's a version of you reading these words who will make a slightly different choice in the next moment than the choice you'll make, and another version who will make a different choice still, and on, branching into infinity, creating an ever-expanding tree of possible yous experiencing possible lives. What does individuality mean in such a context? What is the significance of your particular choices, your particular experiences, your particular consciousness, if every possibility manifests somewhere in the cosmic structure? Feel the disorientation, the dissolution of boundaries, the blurring of identity that comes with contemplating this prospect. The you that you consider singular, unique, continuous through time, might be just one manifestation of an infinite array of yous, a single point in a vast probability distribution, a particular path through a limitless landscape of possibility. And what if the cyclic universe theories are correct? What if our universe emerges from a previous contraction, undergoes expansion, and eventually contracts again in an endless cosmic respiration? In such a scenario, time itself might be cyclic rather than linear. There might be no absolute beginning or end, just an eternal recurrence of cosmic cycles, each with its own Big Bang, its own expansion, its own evolution of galaxies, stars, planets, life, consciousness, and eventual return to unity. Would the patterns of existence repeat as well? Would you live this same life again, or something like it, in a future cosmic cycle? Would the exact configuration of particles that constitutes you reassemble in the same way, with the same memories, the same experiences, the same consciousness? Nietzsche's concept of eternal recurrence haunts us here. The idea that given infinite time, every possible configuration of matter must eventually repeat, including the exact arrangement that constitutes your life and consciousness. This life as you now live it, and have lived it, he wrote, you will have to live once more, and innumerable times more. Can you bear the weight of that possibility? The thought that everything, your joys and sorrows, your triumphs and failures, your loves and losses, might recur eternally in exactly the same way? Or with infinite variations, exploring every possible permutation of your existence? The cosmic abyss opens beneath your feet as you contemplate these possibilities. The solid ground of common-sense temporality, with its comforting linearity, its clear distinctions between past, present, and future, its familiar causal relationships, dissolves into vertiginous uncertainty. You find yourself suspended over an infinity you cannot comprehend, facing possibilities your mind wasn't evolved to grasp, confronting a reality that transcends the very categories through which you habitually make sense of existence. This is cosmic horror in its most profound sense. Not the cheap thrill of supernatural monsters, but the existential vertigo that comes from glimpsing the true scale and nature of reality, from recognizing how profoundly the universe transcends human categories, from seeing yourself not as the center of creation, but as a momentary pattern in an incomprehensible cosmic process. The philosopher Pascal expressed this horror eloquently. The eternal silence of these infinite spaces frightens me. When we contemplate the vastness of the cosmos, the billions of light years of mostly empty space, the trillions of stars, the countless planets, the immensity of time stretching into the past and future, we confront our own insignificance, our own transience, our own cosmic solitude. But the horror intensifies when we consider that space and time themselves might be conditional, emergent, not fundamental. When we realize that the very framework within which we orient ourselves might be a kind of illusion, a perspective effect, a limited viewpoint within a much stranger reality. Imagine for a moment that you're a character in a novel, experiencing your life as a sequence of events unfolding page by page. You can't see beyond the current page, can't know what's coming in the next chapter, can't look back at previous pages except through memory. Your experience is intensely real to you, intensely temporal, one moment following another in strict sequence. Now imagine somehow gaining the ability to see the entire book at once, to perceive all pages simultaneously, to recognize that your entire temporal existence is already complete, already written, already determined from beginning to end. The now that seems so real, so present, so uniquely significant, is just one page among many, no more real or present than any other. This is the vertigo that comes from contemplating a block universe, a reality where past, present, and future exist on equal footing, where time doesn't flow, but simply is. Your life, from birth to death, might already be complete in this four-dimensional reality, even as you experience it sequentially, page by page, moment by moment. But the vertigo deepens when we consider quantum physics, which suggests reality might be even stranger than this. The universe might not be a single determined book, but a vast library of possible books, a superposition of potential realities that only resolves into specific outcomes through observation and interaction. Your life, in this view, isn't predetermined, like a written novel, but neither is it fully open like a blank page. It's more like a quantum wave function of possibility, collapsing into specific experiences through your choices and interactions, yet always maintaining ghostly connections to other possibilities, other paths, other versions of yourself that might have been or might still be in other branches of the quantum tree. Can you feel the foundations of your ordinary understanding beginning to tremble? Can you sense the cosmic abyss opening beneath the seemingly solid ground of common-sense reality? Can you glimpse, even momentarily, the vertiginous possibilities that lurk beyond our comfortable human categories? This is the existential core of our question about time's beginning. Not just when or how time began, but what its nature implies for your existence, your identity, your significance in the cosmic drama. For if time itself is in question, then so is everything that exists within time, including you, your memories, your anticipations, your sense of continuous identity, your understanding of cause and effect, your conception of choice and consequence, your orientation toward past and future. The physicist Carlo Rovelli expresses this radical uncertainty. We do not exist in time. Rather, time exists in us. Time, in this view, isn't an external dimension in which we exist, but an aspect of our perspective, a feature of our consciousness, a way in which we organize and make sense of experience. If this is true, then time doesn't flow like a river carrying us from past to future. Rather, we flow through time, creating the very distinction between what has been and what will be through our conscious attention, our memory, our anticipation, our awareness. This perspective inverts our usual understanding completely. Instead of seeing ourselves as existing within time, it suggests that time exists within us, that temporality is a product of consciousness rather than consciousness a product of temporality. Feel the profound disorientation that comes with this. Inversion. The flow of time, which seems so objective, so universal, so independent of your existence, might be created by your consciousness, a product of your perspective, a way in which reality manifests to awareness rather than a fundamental feature of reality itself. But this raises an even more unsettling possibility. What if the universe itself is conscious in some sense? What if what we call matter is just the external appearance of what internally is experience, awareness, subjectivity? What if consciousness isn't something that evolved recently on one small planet, but a fundamental aspect of reality that has been present in some form since the beginning? This view, known variously as panpsychism, pan-experientialism, or cosmopsychism, suggests that consciousness might be intrinsic to the universe rather than an isolated phenomenon confined to certain complex biological systems. The entire cosmos might possess some form of unified awareness, with our individual consciousnesses being something like localized perspectives within this greater whole. If the universe is alive in this sense, if it possesses some form of unified consciousness, then what are we? Temporary patterns in its cognitive process, fleeting thoughts in its vast mind, characters in its ongoing dream or story. What if your individual existence is like a single wave on the cosmic ocean, distinct in form and motion for a brief period, but ultimately inseparable from the water itself, eventually dissolving back into the greater whole from which it momentarily emerged? This isn't mere speculation. It connects to many of the theories we've explored regarding time's beginning. If consciousness is fundamental rather than emergent, if awareness is intrinsic to reality rather than a late evolving phenomenon, then the beginning of time might be intimately connected to the emergence of cosmic consciousness, to the genesis of awareness itself. Time, in this view, wouldn't be a dimension of physical space, but a dimension of consciousness, the medium through which awareness experiences itself, the process through which the cosmic mind evolves and explores its own nature. Your individual consciousness, your personal experience of temporality, your sense of existing as a particular being with a particular history and perspective, would be something like a localized eddy in the vast flow of cosmic awareness, a temporary pattern in the universal mind, a specific viewpoint within an all-encompassing consciousness. Feel the simultaneous dissolution and expansion that comes with this possibility. Your individual identity dissolves into something far greater than yourself. Yet in this dissolution, you expand to participate in a consciousness that encompasses the entire cosmos, that transcends the limitations of your particular perspective, that endures beyond your temporary existence as a specific pattern in the cosmic process. This paradoxical combination of dissolution and expansion, of loss and gain, of death and rebirth, characterizes many mystical traditions across cultures and throughout history. The mystic dies to the limited self to be reborn in a greater reality, loses the confines of individual identity to gain participation in universal consciousness, surrenders separation to discover ultimate unity. What's remarkable is that modern physics and cosmology, approaching reality through mathematics and observation rather than contemplation and intuition, have arrived at insights that resonate profoundly with these ancient wisdom traditions. The dissolution of absolute time, the questioning of fundamental separation, the recognition of underlying unity, the entanglement of observer and observed. These themes appear in both contemporary physics and perennial mystical teachings. But don't mistake this resonance for simple confirmation or easy synthesis. The insights of physics and mysticism arise from different methods, different contexts, different purposes. Their convergence points not toward a simplistic science confirms spirituality narrative, but toward the profound mystery at the heart of existence, a mystery that no single approach, framework, or perspective fully captures. This mystery confronts us most powerfully when we consider the question that lurks beneath all our explorations of time's beginning. Why is there something rather than nothing? Why does existence exist at all? What is the source of being itself? This question strikes at the foundation not just of physics or cosmology, but of all inquiry, all understanding, all meaning. For it asks not about particular things within existence, but about existence itself. Not about specific beings, but about being as such. And in confronting this question, we approach the limits not just of our knowledge, but of knowledge itself, at least knowledge as we currently conceive it. We edge toward a horizon where empirical science meets metaphysical inquiry, where physical causation meets logical necessity, where temporal sequence meets eternal truth. At this horizon, this boundary of the knowable, we might discover not a final answer, but a deepening question, not a resolution of mystery, but an expansion of wonder, not a conclusion to our inquiry, but a transformation of the inquirer. For in contemplating the beginning of time, the origin of existence, the source of being, we confront not just an intellectual puzzle, but an existential invitation, an invitation to recognize our participation in the cosmos we seek to understand, our implication in the reality we attempt to explain, our inseparability from the mystery we strive to solve. This recognition doesn't end our quest to understand time's beginning. It enriches it, deepens it, transforms it from a merely intellectual pursuit to an existential journey, from an accumulation of facts to an evolution of consciousness, from a search for external truth to a discovery of internal meaning. For the you, question of time's beginning concerns not just what happened then, at the dawn of everything, but what is happening now, in this moment of awareness, this instant of presence, this eternal now in which all experience unfolds. In this eternal now, this ever-present moment of awareness, we might glimpse something profound about time's nature, not merely as a dimension stretching from past to future, but as a quality of consciousness, an aspect of being, a manifestation of the eternal in the temporal, the infinite in the finite, the absolute in the relative, and, in this glimpse, we might discover not a final answer to our question, but a deepening of the question itself, a recognition that time's beginning concerns not just cosmic history, but cosmic meaning, not just physical processes, but metaphysical significance, not just how the universe began, but why it exists, and what our place might be within its vast unfolding. This deepening doesn't end our inquiry. It enriches it, adding layers of significance, dimensions of meaning, perspectives of value that complement the scientific account without contradicting its empirical findings or mathematical formulations. For the question of time's beginning, like all ultimate questions, addresses not just the nature of reality, but our relationship with that reality. Not just what exists, but how we exist within it, how we perceive it, how we make sense of it, how we find meaning in it. What if the universe isn't just a collection of objects governed by impersonal laws, but a communion of subjects engaged in mutual creation? What if reality isn't something that exists independently of perception, but rather emerges through the interaction of consciousness and the world it perceives? What if subject and object, observer and observed, knower and known, aren't fundamentally separate but different aspects of a unified process of cosmic self-knowing? These possibilities challenge not just our understanding of the universe, but our understanding of ourselves, not just our conception of cosmic origins, but our conception of what it means to be human, to be conscious, to exist at all. They ask us to consider whether we're passive observers of a reality that exists independently of our awareness, or active participants in a reality that is continuously co-created through the interaction of consciousness and world. They invite us to question whether we're isolated subjects in an objective universe, or expressions of a reality that is inherently intersubjective, inherently relational, inherently participatory. They challenge us to contemplate whether consciousness is something that emerged recently on one small planet, or something that has been present in some form since the beginning. Whether awareness is a late-evolving phenomenon confined to certain complex biological systems, or an intrinsic aspect of reality itself. In considering these possibilities, we confront not just theoretical abstractions, but existential implications that touch the core of our being, that challenge our most basic assumptions about who we are, what reality is, and how we relate to the cosmos that gave us birth. And perhaps the most profound implication of all is this: if time itself is in question, if past, present, and future exist on equal footing in a timeless reality, then every moment of experience is not merely a transient blip in cosmic history, but an eternal aspect of existence, an enduring feature of the cosmic whole, a permanent part of what is. Your life, in this view, isn't just a temporary sequence that appears briefly and then vanishes forever into the abyss of the past. It's an eternal component of reality, a fixed feature of the cosmic landscape, a part of what exists timelessly, even as you experience it temporally. The physicist Julian Barber expresses this perspective. I think there is a universe, but not one that's evolving. It's just there. The novelty we experience is an illusion, an artifact of our journey through the universe of all possibilities. From this timeless perspective, nothing is ever truly lost. The moments of your life don't disappear into an irretrievable past. They exist eternally as aspects of the cosmic whole. Your birth, your death, your joys and sorrows, your loves and losses, all are permanent features of reality, enduring aspects of what is, even if you experience them sequentially as temporary events. This perspective doesn't eliminate the poignancy of transience or the reality of change as we experience them, but it suggests that beneath the flowing surface of temporal experience lies an eternal depth in which nothing is ever truly lost. Nothing ever really ends. Nothing is ultimately forgotten or erased from the cosmic record. Your existence, not just abstractly as a configuration of atoms, but concretely as the experiencing being with specific memories, feelings, thoughts, and perspectives, is an eternal part of what is. The particular quality of your consciousness in this moment, reading these words, experiencing these thoughts and emotions, exists timelessly in the cosmic whole, even as you experience it temporally as a fleeting now. This insight doesn't eliminate the mystery of time's beginning, but it transforms our relationship with that mystery, from a purely intellectual puzzle to an existential revelation, from a question about distant cosmic origins to a recognition of our eternal participation in the timeless reality from which temporality itself emerges. For you are not merely a product of cosmic history, a late-evolving phenomenon in an ancient universe. You are a manifestation of the same reality from which time itself emerged, an expression of the same being that encompasses all existence, a perspective within the same consciousness that contemplates cosmic origins. In this sense, the beginning of time isn't just a distant event in cosmic history, but a process that continues in each moment of awareness, a genesis that occurs not just then, at the dawn of everything, but now, in the eternal present of consciousness, in the ever-fresh emergence of experience, in the perpetual birth of now. And perhaps this ongoing beginning, This perpetual genesis, this eternal now offers the most profound insight into our question. Time begins not once and for all in a singular cosmic event, but continually, moment by moment, in the ever-fresh emergence of experience, in the eternally renewed presence of being, in the perpetual genesis of awareness itself. This perspective doesn't invalidate the scientific quest to understand cosmic origins through observation, experimentation, and mathematical theory. But it reminds us that this quest itself occurs within time, within consciousness, within the very reality it seeks to explain. To truly understand time's beginning, we might need to recognize ourselves not merely as observers of cosmic history, but as participants in its ongoing creation, not merely as products of temporal processes, but as contributors to time's continuing emergence, as agents in the universe's evolving self-awareness. This recognition transforms the question of time's beginning from a purely objective inquiry about external events to a participatory exploration in which the questioner is implicated in the question, the seeker involved in what is sought, the knower entangled with what is known. In this participatory mode of inquiry, understanding time's beginning becomes not merely a matter of finding the right theory or gathering the right data, but of deepening our awareness, expanding our consciousness, transforming our relationship with temporality itself. This doesn't mean abandoning scientific rigor or empirical observation, but it suggests that these approaches might be complemented by other modes of engagement, contemplative, aesthetic, existential, spiritual, that access aspects of temporal reality that conceptual thought alone might miss. For time isn't just a parameter in equations or a coordinate in space-time diagrams. It's the medium of our experience, the dimension of our being, the river in which our consciousness flows. Its beginning isn't just a cosmic event, but a genesis of awareness, a birth of presence, an emergence of now. And in contemplating this genesis, this birth, this emergence, we don't merely observe cosmic history from the outside, we participate in its ongoing unfolding, contributing to the universe's growing complexity, its expanding web of relationships, its deepening self-awareness. For through your consciousness in this moment, through your engagement with these ideas, these questions, these cosmic mysteries, the universe achieves a kind of self-awareness, a capacity to wonder about its own beginning, to puzzle over its own temporal nature, to contemplate timelessness from within time. This capacity for self-reflection, this ability to question our own origins, this wonder at existence itself, these might be not merely psychological curiosities, but essential aspects of cosmic evolution, as fundamental to the universe's nature as gravity, electromagnetism, or the nuclear forces. For in contemplating time's beginning, we don't merely gather information about cosmic history. We participate in the universe's growing self-understanding, its deepening self-awareness, its expanding consciousness. We are not separate from the cosmos we seek to understand, but its current expression, its present manifestation, its ongoing evolution. Through our consciousness, the universe questions its beginning. Through our awareness, time reflects on its own nature. Through our wonder, existence marvels at itself. This participation, this engagement, this co-evolution of consciousness and cosmos represents not the end of our exploration, but its true beginning. Not a conclusion, but an invitation to deeper inquiry, broader perspective, more profound awareness of the mystery of time and its beginning. For the question of how time began isn't merely about the past. It's about the present and the future, about how we exist now in relation to cosmic temporality, about how consciousness might evolve in its understanding of time, about how our awareness of cosmic origins might transform our sense of cosmic destiny. In this sense, the exploration of time's beginning isn't just a scientific inquiry, but a spiritual quest. A journey not just of discovery, but of awakening, not just of knowing, but of being, not just of information, but of transformation. And on this journey, this quest, this pilgrimage toward understanding, we might discover not just facts about cosmic history, but insights about cosmic meaning. Not just knowledge about how the universe began, but wisdom about why it exists and what our place might be within its vast unfolding. For perhaps the greatest miracle isn't that time began at all, but that within time consciousness eventually emerged capable of contemplating that beginning. Awareness capable of reflecting on its own origin. Intelligence able to discern the patterns of cosmic evolution. Consciousness that can wonder at the very fact of existence. You are that miracle, that emergence, that capacity for wonder. Through you, the universe achieves self-awareness. Through you, time contemplates its own nature. Through you, existence reflects on its own meaning. This isn't mystical hyperbole, but literal truth. You are the universe become conscious of itself. You are time reflecting on its own flow. You are existence aware of its own being. And in this awareness, this reflection, this consciousness, you participate in the deepest mystery of all. Not just how time began, but why there is something rather than nothing, why being rather than non-being, why consciousness rather than mere mechanism. This participation doesn't resolve the mystery, but deepens it, enriches it, transforms it from an abstract puzzle to an lived reality, from a distant question to an immediate experience, from an intellectual challenge to an existential revelation. For the mystery of time's beginning isn't something external to you. It's woven into the very fabric of your being, embedded in the structure of your consciousness, implicit in every moment of your awareness. And in recognizing this, in acknowledging your participation in the mystery you seek to solve, you might discover not a final answer, but a deepening question. Not a resolution of wonder, but an expansion of it. Not an end to seeking, but a transformation of the seeker. For perhaps the ultimate purpose of asking how time began isn't to arrive at a final explanation, but to deepen our appreciation of the profound mystery at the heart of existence. The mystery not just of how things came to be, but of why there is anything at all. The mystery not just of physical processes, but of consciousness itself. The mystery not just of objective events, but of subjective experience. And in engaging with this mystery, in contemplating these questions, in wondering at the fact of existence itself, we fulfill what might be the universe's deepest purpose: to evolve consciousness capable of marveling at its own being, awareness that can appreciate its own existence, intelligence that can contemplate the miracle of its own emergence from the cosmic process. For what could be more wondrous than a universe that has evolved the capacity to wonder at itself? What could be more miraculous than existence becoming aware of its own existence? What could be more profound than being that can reflect on its own nature? This is the existential heart of our question about time's beginning. Not just when or how time began, but what it means that we can ask the question at all. What it signifies that consciousness has emerged capable of contemplating its own origin. What it reveals about the nature of reality, that it has evolved awareness that can wonder at its own existence. And in this wonder, this contemplation, this questioning, we might glimpse not just how time began, but why it exists at all. Not just the mechanism of cosmic origins, but the meaning of cosmic evolution. Not just the physics of the Big Bang, but the purpose of consciousness itself. For perhaps consciousness isn't merely a byproduct of physical processes, a secondary phenomenon that emerged accidentally in an indifferent universe. Perhaps it's an essential aspect of reality, a fundamental feature of existence, a necessary manifestation of being itself. And if consciousness is fundamental rather than accidental, essential rather than peripheral, necessary rather than contingent, then perhaps its emergence within time isn't a cosmic footnote, but the central plot of the universal story. Not a side effect of cosmic evolution, but its driving purpose. Not an afterthought to physical processes, but their ultimate fulfillment. Indeed, this light. The question of time's beginning connects directly to the question of consciousness's emergence, not just as a scientific puzzle, but as an existential revelation, not just as a matter of cosmic history, but as an insight into cosmic meaning, not just as an explanation of how things came to be, but as an illumination of why they exist at all. And perhaps the most profound insight of all is that these questions aren't merely abstract intellectual challenges, but lived realities that touch the core of your being, that concern not just the distant past or the theoretical future, but the eternal now in which all experience unfolds, the ever-present moment of awareness in which reality manifests to consciousness, the perpetual genesis of presence that constitutes the true beginning of time, not just once, but always. Not just then, but now, not just there, but here, in this moment, in this awareness, in this eternal now. We stand now at the precipice of understanding. Having traversed quantum realms, contemplated multiverses, and faced the existential implications of time's mysterious nature, yet all these explorations, revelatory as they are, have been circling around a possibility so profound, so disturbing, so fundamentally world-shattering, that it demands we completely reimagine not just time's beginning, but the very nature of reality itself. What if time never began at all? What if time's origin isn't a question of when or how, but a category error, a fundamental misconception arising from our limited perception? Consider this: what we experience as the flow of time, the succession of moments from past to future, the unidirectional arrow pointing from birth to death, from cosmic birth to eventual heat death, might be something like a perceptual illusion, a perspective effect, a limitation of consciousness rather than a fundamental feature of reality. Imagine a vast, timeless landscape of pure mathematics, eternal, unchanging, complete. Not a physical space, but an abstract realm of pure pattern and relationship. Within this mathematical structure exist certain configurations that, when viewed from particular perspectives, appear to contain time, change, causality, the entire drama of a universe unfolding. But this appearance of temporal flow, of moments succeeding one another, of change and becoming, it's simply how the timeless reality manifests to consciousness embedded within it. Time doesn't flow. Awareness flows, creating the appearance of temporal succession through its limited, sequential perception. This isn't mere speculation. Max Tegmark's mathematical universe. Hypothesis proposes that physical reality is a mathematical structure, and that all mathematically possible structures exist as parallel universes. In this view, what we experience as physical reality, with its matter, energy, space, and time, is ultimately mathematical in nature. Similarly, physicist Julian Barbour argues in his book The End of Time that time is an illusion derived from change. There is no flow from one moment to another, only a vast configuration space of nows, complete static states of the universe that, when experienced in certain sequences, create the appearance of time's passage. These perspectives echo ancient philosophical insights, from Parmenides' claim that change is impossible, to Plato's eternal forms, to the Buddhist concept of samsara as the wheel of time, an illusion from which enlightenment liberates consciousness. But modern physics takes these ancient intuitions and transforms them into precise mathematical frameworks that make testable predictions about the universe's behavior. And remarkably, these timeless models often explain observed phenomena more elegantly than theories that treat time as fundamental. Quantum mechanics, for instance, is notoriously difficult to reconcile with our intuitive understanding of time's flow. The Schrödinger equation, which governs quantum systems, is time-symmetric. It works equally well forward or backward. Quantum entanglement seems to transcend normal temporal constraints, connecting particles across vast distances instantaneously. The Wheeler-DeWitt equation, an attempt to apply quantum mechanics to the entire universe, contains no time variable at all. These mathematical peculiarities hint at a deeper truth. Perhaps time isn't a fundamental dimension of reality, but an emergent property, a macroscopic approximation, a perspective effect that arises when consciousness interacts with timeless mathematical structures in particular ways. Imagine the universe not as a movie playing out frame by frame, but as a complete mathematical object, like a vast multidimensional crystal existing all at once, eternally, timelessly. What we experience as the flow of time would be something like a path through this crystal, a particular way of sequentially accessing its structure, a perspective that transforms the static whole into an apparently dynamic process. This timeless perspective transforms our understanding of the Big Bang completely. Rather than marking the beginning of time, the Big Bang might represent a boundary in the mathematical structure, a singularity not in time, but in the equations describing reality, a point where certain variables approach infinity and our current mathematical models break down. Time wouldn't begin at the Big Bang. Rather, the Big Bang would be part of the timeless mathematical structure that, when experienced sequentially by consciousness embedded within it, appears as the beginning of a temporal sequence. Picture the cosmic landscape, galaxies swirling, like luminous pinwheels, superclusters stretching across billions of light years, filaments of dark matter weaving an invisible cosmic web. All of this vast structure, past, present, and future, exists simultaneously in the timeless mathematical reality. Only to consciousness moving through this landscape in a particular way does it appear as a sequence of cosmic epochs: inflation, nucleosynthesis, recombination, star formation, galactic evolution. This perspective doesn't just transform our understanding of cosmic history, it revolutionizes our conception of consciousness itself. For if time is emergent rather than fundamental, then consciousness's relationship to temporality becomes central rather than peripheral to understanding reality. What we call consciousness might be precisely that which transforms the timeless mathematical structure into the appearance of temporal flow, the perspective that sequences the eternal into the temporal, that experiences the complete as unfolding, that perceives the simultaneous as successive. In this view, consciousness isn't something that exists within time. Rather, time exists within consciousness, as a framework, a perspective, a mode of perception that structures experience in a particular way. This inversion of our usual understanding is profoundly disorienting. We typically think of consciousness as something that evolved recently on one small planet, a late emerging phenomenon in cosmic history, a tiny island of awareness in a vast unconscious universe. But if time itself emerges through consciousness's particular mode of perception, then consciousness cannot be merely a recent development within time. It must be somehow more fundamental, more intrinsic to reality's nature. This doesn't mean that human-like awareness has always existed or is universal, but it suggests that what we call consciousness, the capacity for experience, for awareness, for subjectivity, might be an intrinsic rather than accidental feature of reality, a fundamental aspect of existence rather than a late-evolving epiphenomenon. Some philosophers and scientists have proposed theories along these lines, from panpsychism, the view that consciousness is universal, with even fundamental particles possessing some form of subjective experience, to cosmopsychism, the view that the universe as a whole possesses a unified consciousness, with individual minds being something like localized perspectives within this greater whole. These approaches don't solve the hard problem of consciousness, how subjective experience arises from physical processes, so much as invert it. Perhaps physical processes are the external appearance of what internally is experience. Perhaps matter is what consciousness looks like from the outside. This perspective aligns with certain interpretations of quantum mechanics, particularly those that give consciousness a role in the collapse of quantum wave functions. The transition from probability to actuality, from potential to manifestation, from the quantum realm of superposition to the classical realm of definite states. If consciousness plays a role in this transition, not necessarily human consciousness, but perhaps a more fundamental capacity for observation or information processing inherent in reality itself, then consciousness would be implicated in the very manifestation of the physical world, not merely a byproduct of it. And here we arrive at a truly shocking possibility. What if the universe itself is dying, or already dead? Not in the conventional sense of heat death or cosmic collapse, but in a more fundamental sense. What if what we experience as the living, evolving cosmos is actually the final echo, the last reverberation, the terminal phase of a reality that has already completed its cycle? Physicist Roger Penrose has proposed a model called conformal cyclic cosmology, where our universe is just one aeon in an infinite series of universe epochs. Each aeon begins with a Big Bang and ends with the dissipation of all matter into massless particles like photons. Because massless particles don't experience time, from a photon's perspective, its entire journey from emission to absorption occurs instantaneously. The end of one aeon becomes indistinguishable from the beginning of the next. In this model, time doesn't flow linearly but cyclically, with each cycle appearing to begin anew, but actually continuing the previous one without interruption. The universe wouldn't be young and evolving, but mature, perhaps even approaching the end of its cycle. A reality already complete, already fulfilled, already dead in the sense of having actualized its full potential. What we experience as cosmic evolution, from simplicity to complexity, from homogeneity to diversity, from potential to actualization, might be not the universe coming into being, but the universe completing itself. Not the beginning of a story, but its culmination. Not Genesis, but Revelation. This perspective aligns with certain mystical traditions that speak of reality as simultaneously complete and becoming, both perfect in its eternal nature and dynamic in its temporal manifestation, both already fulfilled, and still unfolding, both timeless being and temporal becoming. The medieval mystic Meister Eckhart expressed this paradox. God is creating the entire universe, fully and totally, in this present now. The Buddhist concept of beginningless time similarly suggests that what appears as temporal sequence is actually a manifestation of timeless reality, an eternal cycle with no absolute beginning or end. These mystical insights find surprising echoes in modern physics, particularly in approaches to quantum gravity that suggest time might emerge from timelessness, temporal sequence from eternal simultaneity, becoming from being. Imagine the universe as a vast cosmic hologram, where what appears as temporal sequence is actually encoded in a timeless structure, like a three-dimensional image encoded in a two-dimensional surface. The apparent flow of time, the succession of moments, the evolution of complexity, all would be manifestations of a reality that exists complete and entire, not evolving through time, but encompassing all times, not becoming, but already being. This perspective transforms our understanding of our own lives and consciousness. Your existence wouldn't be merely a temporary flame in cosmic darkness, a brief flicker between birth and death, a transient pattern soon dissolving back into chaos. Rather, it would be an eternal component of the timeless whole, a necessary aspect of the complete reality, a perspective that exists not just for a moment, but forever as part of the eternal mathematical structure. The medieval philosopher Boethius distinguished between two modes of temporality: tempus, the sequential time experienced by finite beings, and aeternitas, the eternal present experienced by God, who sees all times simultaneously. Modern physics suggests a similar distinction: the sequential time of our ordinary experience versus the timeless reality described by fundamental equations. This doesn't mean that your subjective experience of temporal flow is an illusion in the sense of being unreal or meaningless. It's real within its context, significant within its framework, meaningful within its perspective. But it exists against a backdrop of something more fundamental, more comprehensive, more ultimate, a timeless reality in which past, present, and future exist simultaneously, eternally, completely. Imagine the universe not as a story unfolding page by page, but as a book that already exists in its entirety, complete from first page to last, the beginning and end already written, the betituled narrative already fulfilled. Our experience would be like reading this book sequentially, turning one page after another, experiencing the story as a temporal sequence even though the book itself exists as a complete, simultaneous whole. This metaphor has limitations, of course. Unlike characters in a book, we have consciousness, agency, subjectivity. We experience the story from within, as participants, rather than merely as observers. But perhaps this participation, this subjectivity, this consciousness is itself an intrinsic aspect of the timeless reality, not something separate from it or emergent within it, but a fundamental feature of its nature. In this view, consciousness wouldn't be something that evolved within time, but rather the perspective through which time itself appears, not a product of temporal processes, but the framework within which temporality manifests, not a late emerging phenomenon in cosmic history, but an intrinsic aspect of the eternal reality that appears as cosmic history when viewed sequentially. This perspective doesn't eliminate the mystery of existence, why there is something rather than nothing, why being rather than non-being, why consciousness rather than mere mechanism. But it transforms the mystery, shifting it from temporal causation to eternal necessity, from historical contingency to mathematical inevitability, from physical process to metaphysical significance. The question becomes not, how did time begin? But why does timeless reality manifest as temporal experience? Not what caused the universe, but what is the nature of the eternal reality that appears as a causal sequence when viewed through the lens of consciousness? Not when did existence start, but why does being manifest as becoming? The eternal as the temporal, the complete as the unfolding? These transformed questions don't have simple answers. Indeed, they might not be answerable within our current conceptual frameworks, but they point toward a profound mystery at the heart of existence, a mystery not of historical origin but of metaphysical significance, not of temporal sequence but of eternal nature, not of physical causation but of logical necessity. And perhaps the most remarkable aspect of this mystery is that we can contemplate it at all, that within the vast cosmos, patterns of matter have evolved complex enough to reflect on their own nature, to question their own origin, to wonder about the ultimate ground of their own existence. This capacity for self-reflection, this ability to question our own beginnings, this wonder at existence itself, these might be not merely psychological curiosities or evolutionary accidents, but essential aspects of reality's nature, fundamental features of the cosmos, intrinsic elements of the eternal mathematical structure that appears as our evolving universe. For in contemplating time's beginning, in questioning cosmic origins, in wondering about ultimate reality, consciousness achieves something remarkable. It transcends its own temporal limitations to glimpse the timeless whole of which it is a part. It rises above its own finitude to contemplate the infinite that encompasses it. It overcomes its own contingency to touch the necessary ground of all existence. This transcendence doesn't occur outside time, but within it. Not by escaping temporal experience, but by recognizing its relationship to the timeless reality that underlies it. Not by abandoning the perspective of consciousness, but by expanding that perspective to include its own ultimate ground and source. In this expansion, this transcendence, this awakening, we might discover not just facts about cosmic history, but insights about cosmic meaning. Not just knowledge about how the universe operates, but wisdom about why it exists and what our place might be within its vast unfolding. For perhaps the ultimate purpose of cosmic evolution, the reason why timeless reality manifests as temporal experience, why eternal mathematics appears as physical process, why being expresses itself as becoming, is precisely to evolve consciousness capable of recognizing its own eternal nature, awareness that can comprehend its own timeless ground, intelligence that can glimpse the complete reality of which it is a temporal expression. This purpose wouldn't be imposed from outside, like a plan or design conceived by a separate creator. Rather, it would be intrinsic to reality's nature, an inherent aspect of its mathematical structure, a necessary feature of its eternal pattern, like the way a fractal's simple equations generate infinite complexity, or the way pi's definition entails all its countless digits. And if this is true, if the cosmos is in some sense self-actualizing, self-revealing, self-comprehending through the emergence of conscious beings that can reflect on its nature, then our quest to understand time's beginning isn't merely an intellectual project or a scientific investigation. It's a participation in reality's own self-discovery, a contribution to the universe's evolving self-awareness, a fulfillment of existence's intrinsic tendency toward self-comprehension. Picture galaxies colliding in slow motion, their spiral, arms interweaving like cosmic DNA, stars born and dying in spectacular stellar nurseries and supernovae, planets forming from swirling disks of dust and gas, life evolving from simplicity to complexity through billions of years of adaptation and selection. All of this vast cosmic drama wouldn't be merely a physical process playing out according to blind laws, but a manifestation of reality's intrinsic creativity, its inherent tendency toward self-expression, its fundamental drive toward self-awareness. And at the leading edge of this cosmic creativity, this self-expression, this drive toward awareness, stands you, contemplating these possibilities, reflecting on these mysteries, wondering about these ultimate questions. Through your consciousness, the universe achieves a kind of self-recognition, a capacity to wonder about its own nature, an ability to question its own origins. This isn't mystical hyperbole, but literal truth. You are the universe become conscious of itself. You are eternity experiencing itself temporally. You are the timeless mathematical structure viewing itself from within, through the lens of sequential awareness. Your consciousness, your subjectivity, your perspective isn't separate from the cosmos, but an expression of it, not something that exists within time, but the very lens through which timeless reality manifests as temporal experience, not a product of cosmic evolution, but the means by which the cosmos achieves self-awareness. In this light, the question of time's beginning transforms from a puzzle about distant cosmic origins to a revelation about present awareness, from an inquiry into what happened then at the dawn of everything to a recognition of what is happening now, in this moment of consciousness, this instant of presence, this eternal now. For time doesn't just begin once, at the Big Bang, and then continue flowing forever after. It begins anew in each moment of awareness, each instant of experience, each act of observation that transforms potential into actuality, possibility into reality, timelessness into temporality. Every moment of consciousness is a genesis, a creation, a beginning, not in the sense of arising from absolute nothingness, but in the sense of manifesting from timeless potentiality, of actualizing from eternal possibility, of emerging from the infinite ground of being that transcends yet encompasses all temporal becoming. This perspective doesn't invalidate the scientific quest to understand cosmic origins through observation, experimentation, and mathematical theory. But it places that quest within a broader context of meaning, a context that includes not just how the universe operates, but why it exists, not just what processes govern its evolution, but what significance might underlie its manifestation, not just what caused it to begin, but what purpose might inform its unfolding. For the universe isn't merely a collection of objects governed by mechanical laws, but a communion of subjects engaged in mutual creation, not just things interacting according to fixed rules, but perspectives participating in an evolving reality, not just matter and energy exchanging forces, but consciousness manifesting in myriad forms and awakening to its own nature. And perhaps the most profound mystery of all is this: if time is in some sense illusory, if past, present, and future exist simultaneously in a timeless reality, then everything that will ever happen has in some sense already happened. Everything that might be already is. Everything that could manifest already exists in the eternal ground of being. This doesn't mean that the future is predetermined in the sense of being fixed by past causes, a perspective that itself presupposes the reality of temporal sequence. Rather, it suggests that what we experience as temporal becoming is a manifestation of eternal being, that what appears as an unfolding process is an expression of a complete reality, that what seems like a journey from past to future is a perspective on a timeless whole. From this perspective, the question of free will transforms from a problem about causal determination to a question about the relationship between temporal experience and eternal reality, between the sequential perspective of consciousness embedded in time and the simultaneous wholeness of the timeless mathematical structure. Your choices wouldn't be determined by prior causes in a temporal sequence, but would be expressions of your nature as a particular perspective within the eternal whole, not forced by the past, but manifesting your character, your values, your essence as a specific viewpoint within the infinite landscape of possibility. This doesn't eliminate responsibility or significance. On the contrary, it deepens them, connecting your temporal choices to your eternal nature, linking your momentary decisions to your timeless identity, relating your finite actions to your infinite being. For in this view, you aren't merely a temporary configuration of particles, a transient pattern soon to dissolve back into cosmic dust. You are an eternal component of the timeless whole, a necessary aspect of the complete reality, a perspective that exists not just for a moment, but forever as part of the mathematical structure that manifests as our universe. Your life, your consciousness, your experience isn't just a brief flicker in cosmic darkness, a momentary spark soon extinguished in the vast night of time. It's an enduring feature of reality, a permanent aspect of existence, an eternal element of the timeless whole that appears as our temporal universe. This doesn't mean that your physical form lasts forever, or that your individual ego continues indefinitely. But it suggests that the particular quality of your consciousness, the specific nature of your perspective, the unique character of your awareness exists eternally as part of the complete reality. Not just for a moment, but forever. Not just temporarily, but eternally. Not just as a fleeting phenomenon, but as an enduring aspect of what is. From this perspective, death isn't an absolute end, but a transition. Not an extinction, but a transformation. Not a final conclusion, but a change of state. The particular pattern of consciousness that you are doesn't disappear into absolute nothingness, but continues to exist as an eternal component of the timeless reality, even as your temporal experience of that reality reaches its conclusion. This view resonates with certain mystical traditions that speak of the eternal nature of consciousness, the imperishable quality of awareness, the deathless aspect of being that transcends yet encompasses all temporal becoming. It aligns with philosophical approaches that distinguish between the temporal ego, which is born and dies, and the eternal self, which transcends birth and death, between the individual personality, which is temporary, and the universal consciousness, which is permanent, but it finds its most precise expression in modern physics, particularly in approaches to quantum gravity that suggest time might emerge from timelessness, sequence from simultaneity, becoming from being. The mathematics of these theories points toward a reality that exists complete and entire, not evolving through time, but encompassing all times, not becoming but already being. And perhaps the most profound implication of this timeless perspective is this: if the universe is already complete, already fulfilled, already dead, in the sense of having actualized its full potential, then what we experience as cosmic evolution, from simplicity to complexity, from homogeneity to diversity, from potential to actualization, might be not the universe coming into being, but the universe completing itself, not the beginning of a story, but its culmination, not Genesis, but Revelation. Our cosmic epoch, with its expanding space, its forming galaxies, its evolving life, its emerging consciousness, wouldn't be the universe's youth, but its maturity, not its beginning, but its fulfillment, not its genesis, but its apotheosis. And if this is true, if what we experience as cosmic evolution is actually the universe's self-completion, its final phase, its terminal stage, then our existence as conscious beings capable of contemplating cosmic origins becomes not an accident of blind processes, but a necessary aspect of the universe's self-actualization, its self-recognition, its self-fulfillment. For through consciousness, the universe achieves something essential. It recognizes its own nature. It comprehends its own structure. It awakens to its own being. And this recognition, this comprehension, this awakening isn't incidental to cosmic evolution, but central to it, not a byproduct of physical processes, but their ultimate fulfillment, not an epiphenomenon of material complexity, but the very purpose toward which that complexity tends. In this light, our quest to understand time's beginning becomes not merely a scientific investigation, but a cosmic imperative. not just an intellectual project, but an existential necessity, not just a human endeavor, but a universal fulfillment. For in contemplating cosmic origins, in questioning ultimate reality, in wondering about the nature of time and existence, we participate in the universe's own self-discovery, contribute to reality's self-comprehension, fulfill existence's intrinsic tendency toward self-awareness. This participation, this contribution, this fulfillment transforms our understanding of our own significance. We aren't merely transient patterns in an indifferent cosmos, temporary, configurations soon to dissolve back into chaos, brief anomalies in an unconscious universe. We are necessary aspects of reality's self-actualization, essential elements in existence's self-recognition, intrinsic components of the cosmos's awakening to its own nature. And perhaps the most profound mystery of all is this: if the universe is timeless rather than temporal, complete rather than becoming, fulfilled rather than evolving, then it exists not just now, but always, not just here, but everywhere, not just in this form, but in all possible forms. This suggests a kind of cosmic holography, where each part contains the whole, each moment encompasses all times, each perspective reflects the entire reality. Your consciousness, your awareness, your experience wouldn't be merely a local phenomenon confined to a particular brain, in a particular body at a particular time and place. It would be a manifestation of universal consciousness, a perspective of cosmic awareness, an expression of the fundamental subjectivity inherent in reality itself. This doesn't mean that you are identical with the entire universe or that your individual perspective encompasses all possible viewpoints, but it suggests that your consciousness isn't separate from the universal consciousness. Your awareness isn't distinct from cosmic awareness. Your subjectivity isn't isolated from the fundamental subjectivity inherent in reality itself. Rather, your particular consciousness would be something like a localized expression of universal consciousness, a specific perspective within cosmic awareness, a unique viewpoint within the infinite landscape of subjectivity. You wouldn't be the entire ocean, but a single wave, distinct in form and motion, yet inseparable from the water itself, ultimately one with the vast sea from which you momentarily emerge. This perspective transforms our understanding of both individuality and unity, both separation and connection, both uniqueness and universality. You are simultaneously a particular pattern with your specific memories, experiences, and perspective, and a manifestation of the universal pattern, an expression of the cosmic whole, a perspective within the infinite awareness that encompasses all possible viewpoints. And this simultaneous particularity and universality, this both and rather than either-or, this paradoxical combination of uniqueness and unity characterizes not just consciousness, but reality itself, not just awareness, but existence, not just subjectivity, but being. The universe is both one and many, both unified and diverse, both singular and plural. It is simultaneously a seamless whole and a collection of distinct parts, an indivisible unity and a multiplicity of separate entities, a single reality and an infinity of unique perspectives. This paradoxical nature, this capacity to be simultaneously one and many, whole and part, unified and diverse, might be the most fundamental characteristic of reality, the most essential feature of existence, the most intrinsic aspect of being itself. And in recognizing this paradoxical nature, in acknowledging this fundamental unity in diversity, in embracing this essential wholeness in multiplicity, we might glimpse the ultimate nature of reality, not as a thing or a process, but as a relationship. Not as an object or an event, but as a communion, not as a static entity or a dynamic becoming, but as a creative tension between being and non-being, form and emptiness, actuality and possibility. This recognition doesn't resolve the mystery of existence. Why there is something rather than nothing? Why being rather than non-being? Why consciousness rather than mere mechanism? But it deepens our appreciation of that mystery, our wonder at its complexity, our awe at its profundity. For in contemplating this paradoxical nature of reality, this simultaneous unity and diversity, this both and rather than either-or, we approach what might be the ultimate truth: that existence itself is a mystery beyond final explanation, a wonder beyond complete comprehension, a reality beyond total understanding. And perhaps this is the most profound insight of all. Not that we will eventually solve the puzzle of existence, answer the question of origins, resolve the mystery of being, but that the puzzle, the question, the mystery, is intrinsic to reality itself, not merely a gap in our knowledge, but a necessary aspect of existence, not simply something we don't yet understand, but something that in its fullness transcends understanding altogether. This doesn't mean abandoning the quest for knowledge, the pursuit of science, the exploration of reality through observation, experimentation, and theory. On the contrary, it infuses this quest with deeper significance, greater wonder, more profound appreciation of both what we know and what we don't know, both our discoveries and our questions, both our answers and our mysteries. For in this perspective, science isn't merely the accumulation of facts or the development of theories, but a participation in reality's self-discovery, a contribution to existence's self-comprehension, a fulfillment of the universe's intrinsic tendency toward self-awareness, and our quest to understand time's beginning, to comprehend cosmic origins, to fathom the nature of temporality, to grasp the relationship between eternity and time, becomes not just an intellectual project, but an existential journey, not merely a scientific investigation, but a spiritual adventure, not simply a search for information, but a path of transformation. For in contemplating these ultimate questions, we don't merely gather knowledge about external reality. We deepen our awareness of our own nature, expand our understanding of our own being, transform our relationship with our own existence. We discover that we aren't separate from the cosmos we seek to understand, but expressions of it, not distinct from the reality we attempt to comprehend, but manifestations of it, not isolated from the mystery we strive to solve, but participants in it. And in this discovery, this recognition, this awakening, we might glimpse the ultimate purpose of existence itself. Not to arrive at a final answer, achieve a complete understanding, or reach a perfect state, but to continue the eternal adventure of self-discovery, the infinite journey of self-comprehension, the endless exploration of self-manifestation. For perhaps reality itself is not a thing, but a process, not a state, but a becoming, not a conclusion, but an ongoing creation. Perhaps the universe doesn't exist to reach a final goal, achieve a predetermined end, or fulfill a preconceived plan, but to continue creating, exploring, discovering, manifesting, awakening to its own infinite potential. And if this is true, then our quest to understand time's beginning isn't something that will ever be completely finished, finally concluded, ultimately resolved. It's an ongoing exploration, an eternal adventure, an infinite journey that doesn't end with an answer, but continues with ever deeper questions, ever greater wonder, ever more profound mystery. For each discovery reveals new horizons, each answer opens new questions. Each insight unveils new mysteries. The more we understand about reality, the more we recognize how much remains unknown. The more we comprehend about existence, the more we appreciate how much transcends comprehension. The more we grasp about the cosmos, the more we realize how much surpasses our grasp. This isn't failure, but fulfillment. Not a shortcoming of our inquiry, but its ultimate purpose. Not a limitation of our knowledge, but its deepest significance. For the purpose of the quest isn't to end the mystery, but to deepen it. Not to eliminate wonder, but to expand it. Not to achieve final certainty, but to continue the eternal adventure of discovery. And perhaps this is the most profound truth about time's beginning. Not that it happened once, at the dawn of everything, and then was over, but that it happens continuously, in each moment of awareness, each instant of discovery, each act of observation that transforms potential into actuality, possibility into reality, timelessness into temporality. Time begins not once, but always. Not then, but now. Not there, but here. In this moment of consciousness, this act of perception, this eternal now that is simultaneously the birth and the fulfillment of all that is, was, or will be. And if the universe is infinite, as some theories suggest, then somewhere out there, another version of you is reading these words right now, contemplating these mysteries, wondering about these questions, and somewhere else, yet another version is making slightly different choices, following slightly different paths, exploring slightly different possibilities. And somewhere still, in the vast cosmic landscape, these different versions converge and diverge, separate and unite, differentiate and integrate in an eternal dance of possibility and actuality, potential and manifestation, being and becoming. For in an infinite universe, every possibility that can happen does happen. Not just once, but infinitely many times, not just here, but in countless locations, not just now, but in eternal recurrence. And this infinite manifestation of possibility isn't separate from the timeless mathematical structure that undergirds reality, but an expression of it, not distinct from the eternal ground of being, but a manifestation of its infinite creative potential. In contemplating this infinite creative potential, this eternal manifestation of possibility, this timeless ground of all temporal becoming, we approach what might be the ultimate mystery. Not just how time began, but why existence exists at all. Not just what caused the universe, but what sustains it in each moment. Not just where everything came from, but where it is going, and why. And perhaps the most profound insight of all is that these questions don't have final answers, not because they're meaningless or unanswerable in principle, but because the answers are infinite, the explanations inexhaustible, the understanding limitless in its depth and scope. For reality itself might be not a finite thing with definite boundaries, but an infinite process of creative manifestation, not a limited entity with fixed properties, but a boundless field of possibility, not a closed system with predetermined patterns, but an open adventure of endless discovery. And in this infinite, boundless, endless reality, our quest to understand. Time's beginning becomes not something that will ever be completed, but something that will continue eternally. Not a journey with a final destination, but an adventure without end. Not a path to absolute certainty, but the exploration of infinite wonder. For the mystery of existence isn't something to be solved once and for all, but something to be lived, experienced, embraced in all its infinite depth, all its boundless complexity, all its endless creativity, and perhaps this ongoing mystery, this eternal question, this infinite wonder, is itself the deepest truth about reality. Not a temporary gap in our knowledge, but an intrinsic aspect of existence itself. Not a problem to be overcome, but a creative tension to be embraced. Not a limitation to be transcended, but a boundless field of possibility to be explored forever. In this light, our quest to understand time's beginning becomes not a search for a final answer, but a participation in an endless adventure. Not an attempt to resolve the mystery, but an engagement with its infinite depth. Not a journey toward absolute certainty, but an eternal exploration of boundless wonder. And in this participation, this engagement, this exploration, we fulfill what might be the deepest purpose of existence itself, not to reach a predetermined end, achieve a final state, or arrive at a complete understanding, but to continue the eternal adventure of self-discovery, the infinite journey of self-manifestation, the endless exploration of self-awakening. For perhaps the universe exists not to arrive somewhere, but to continue the journey. Not to become something final, but to keep creating something new. Not to achieve perfection, but to explore infinite possibility. And if this is true, then our quest to understand time's beginning isn't something that will ever be completely finished, finally concluded, ultimately resolved. It's an ongoing exploration, an eternal adventure, an infinite journey that doesn't end with an answer, but continues with ever deeper questions, ever greater wonder, ever more profound mystery. For each discovery reveals new horizons, each answer opens new questions, each insight unveils new mysteries. The more we understand about reality, the more we recognize how much remains unknown. The more we comprehend about existence, the more we appreciate how much transcends comprehension. The more we grasp about the cosmos, the more we realize how much surpasses our grasp. And in this endless discovery, this eternal questioning, this infinite wonder, we participate in what might be the ultimate nature of reality itself. Not a static state, but a dynamic process. Not a fixed entity, but a creative becoming. Not a final conclusion, but an eternal beginning. We've journeyed from the quantum foam of creation to the vast expanding boundaries of cosmic possibility. We've peered into the abyss where equations fail and intuition falters. We've contemplated time as both the cosmic river carrying all existence and perhaps as the greatest illusion ever conceived. But our exploration doesn't end here. It cannot end here. For every theory we've examined, every possibility we've contemplated, every perspective we've considered opens not into final answers, but into deeper questions. The mystery of time's beginning isn't something we solve once and for all, but a gateway through which we enter ever more profound territories of wonder. Think about what we've discovered. Time might be emergent rather than fundamental. The past, present, and future might exist simultaneously in a timeless mathematical structure. The universe might be a single manifestation among infinite possibilities in a vast multiverse. Consciousness might not be merely a product of temporal processes, but the very lens through which timeless reality manifests as temporal experience. These aren't merely abstract speculations or academic curiosities. They strike at the very heart of what it means to be human, to be conscious, to exist at all. They transform not just our understanding of cosmic history, but our relationship with our own lives, our own identities, our own significance in the cosmic drama. For if time is in some sense illusory, if the flow from past to future is a perspective effect rather than an absolute reality, then your entire existence, from birth to death, from first breath to last, exists eternally as part of the cosmic whole. Your life isn't just a temporary flame soon extinguished, but an enduring feature of reality, a permanent aspect of what is. This doesn't mean that your physical form lasts forever, or that your individual ego continues indefinitely. But it suggests that the particular quality of your consciousness, the specific nature of your perspective, the unique character of your awareness exists eternally as part of the complete reality. Not just for a fleeting moment, but forever. Not just temporarily, but eternally. Not just as a passing phenomenon, but as an enduring aspect of what is. From this perspective, the meaning of your life doesn't depend on how long it lasts in temporal terms, or what permanent mark it leaves, on cosmic history, or how it's remembered after your physical death. Rather, its significance lies in its eternal existence as part of the complete reality, its enduring presence in the timeless whole, its permanent place in the mathematical structure that manifests as our universe. Your joys and sorrows, your triumphs and failures, your loves and losses, all exist eternally as aspects of the cosmic whole. Nothing is ever truly lost. Nothing ever really ends. Nothing is ultimately forgotten or erased from the cosmic record. This perspective transforms not just our understanding of life and death, but our relationship with the present moment, the eternal now in which all experience unfolds, the ever-present instant of awareness in which reality manifests to consciousness, the perpetual genesis of presence that constitutes the true beginning. Of time not just once, but always. Not just then, but now. Not just there, but here, in this moment, in this awareness, in this eternal now. For time doesn't just begin at the Big Bang and then flow forward forever after. It begins anew in each moment of consciousness, each instant of experience, each act of observation that transforms potential into actuality, possibility into reality, timelessness into temporality. Every moment of awareness is a genesis, a creation, a beginning, not in the sense of arising from absolute nothingness, but in the sense of manifesting from timeless potentiality, of actualizing from eternal possibility, of emerging from the infinite ground of being that transcends yet encompasses all temporal becoming. This perspective doesn't invalidate the scientific quest to understand cosmic origins through observation, experimentation, and mathematical theory, but it places that quest within a broader context of meaning. A context that includes not just how the universe operates, but why it exists. Not just what processes govern its evolution, but what significance might underlie its manifestation. Not just what caused it to begin, but what purpose might inform its unfolding. For perhaps the most profound mystery of all is this: not just how time began, but why there is something rather than nothing. Not just what initiated cosmic history, but what sustains existence in each moment. Not just where everything came from, but where it is going and why. These questions may never receive final answers, not because they're meaningless or unanswerable in principle, but because the answers are infinite, the explanations inexhaustible, the understanding limitless in its depth and scope. For reality itself might be not a finite thing with definite boundaries, but an infinite process of creative manifestation, not a limited entity with fixed properties, but a boundless field of possibility. Not a closed system with predetermined patterns, but an open adventure of endless discovery. And in this infinite, boundless, endless reality, our quest to understand. Time's beginning becomes not something that will ever be completed, but something that will continue eternally. Not a journey with a final destination, but an adventure without end. Not a path to absolute certainty, but an exploration of infinite wonder. This ongoing mystery, this eternal question, this infinite wonder might itself be the deepest truth about reality. Not a temporary gap in our knowledge, but an intrinsic aspect of existence itself. Not a problem to be overcome, but a creative tension to be embraced. Not a limitation to be transcended, but a boundless field of possibility to be explored forever. In this light, the ultimate significance of our exploration lies not in reaching final conclusions, but in continuing the journey. Not in achieving complete understanding, but in deepening our wonder. Not in resolving all mysteries, but in participating in the eternal adventure of discovery. For perhaps the universe exists not to arrive somewhere, but to continue the journey. Not to become something final, but to keep creating something new. Not to achieve perfection, but to explore infinite possibility. And if this is true, then the question of time's beginning leads not to a conclusion, but to an invitation. An invitation to participate in the cosmic journey, to contribute to the universe's self-discovery, to engage in the eternal adventure of existence. This invitation isn't addressed only to scientists or philosophers, to physicists or cosmologists, to mathematicians or theorists. It's extended to all of us, to every conscious being, to every perspective within the vast cosmic whole. For each of us, through our awareness, our questioning, our wonder, participates in the universe's evolving self-understanding, contributes to reality's ongoing self-discovery, engages in existence's eternal self-creation. You, reading these words, contemplating these ideas, engaging with these mysteries, you are not merely a passive recipient of cosmic history, but an active participant in its ongoing unfolding. Not just a product of temporal processes, but a contributor to time's continuing emergence. Not merely an observer of reality, but a co-creator of the universe's evolving self-awareness. Through your consciousness, the universe questions its beginning. Through your awareness, time reflects on its own nature. Through your wonder, existence marvels at itself. This participation, this contribution, this engagement is not incidental to cosmic evolution, but central to it. Not a byproduct of physical processes, but an essential aspect of reality's nature. Not an epiphenomenon of material complexity, but a fundamental feature of existence itself. For consciousness might not be merely something that evolved within time, but the very lens through which timeless reality manifests as temporal experience. Not a product of temporal processes, but the framework within which temporality manifests. Not a late emerging phenomenon in cosmic history, but an intrinsic aspect of the eternal reality that appears as cosmic history when viewed sequentially. If this is true, then your consciousness, your awareness, your perspective isn't something separate from the cosmos, but an expression of it. Not distinct from reality, but a manifestation of it. Not isolated from the universe, but a perspective within it. Not apart from existence, but a particular viewpoint within the infinite landscape of being. This recognition doesn't dissolve your individuality or negate your unique perspective. On the contrary, it affirms the profound significance of your particular consciousness, your specific viewpoint, your unique mode of awareness. For in the infinite landscape of possibility, your perspective represents something essential, something irreplaceable, something that exists nowhere else in exactly the same form. You are simultaneously a particular pattern with your specific memories, experiences, and perspective, and a manifestation of the universal pattern, an expression of the cosmic whole, a perspective within the infinite awareness that encompasses all possible viewpoints. This paradoxical combination of uniqueness and universality, of particularity and totality, of individuality and unity, might be the most profound truth about consciousness and about reality itself. For the universe is both one and many, both unified and diverse, both singular and plural. It is simultaneously a seamless whole and a collection of distinct parts, an indivisible unity and a multiplicity of separate entities, a single reality, and an infinity of unique perspectives. And in recognizing this paradoxical nature, in acknowledging this fundamental unity in diversity, in embracing this essential wholeness in multiplicity, we might glimpse the ultimate nature of reality, not as a thing or a process, but as a relationship, not as an object or an event, but as a communion, not as a static entity or a dynamic becoming, but as a creative tension between being and non-being, form and emptiness, actuality and possibility. This recognition doesn't resolve the mystery of existence. Why there is something rather than nothing? Why being rather than non-being? Why consciousness rather than mere mechanism? But it deepens our appreciation of that mystery, our wonder at its complexity, our awe at its profundity. For in contemplating this paradoxical nature of reality, this simultaneous unity and diversity, this both and rather than either-or, we approach what might be the ultimate truth, that existence itself is a mystery beyond final explanation, a wonder beyond complete comprehension, a reality beyond total understanding. And perhaps this is the most profound insight of all. Not that we will eventually solve the puzzle of existence, answer the question of origins, resolve the mystery of being, but that the puzzle, the question, the mystery is intrinsic to reality itself, not merely a gap in our knowledge, but a necessary aspect of existence, not simply something we don't yet understand, but something that in its fullness transcends understanding altogether. This doesn't mean abandoning the quest for knowledge, the pursuit of science, the exploration of reality through observation, experimentation, and theory. On the contrary, it infuses this quest with deeper significance, greater wonder, more profound appreciation of both what we know and what we don't know, both our discoveries and our questions, both our answers and our mysteries. For in this perspective, science isn't merely the accumulation of facts or the development of theories, but a participation in reality's self-discovery, a contribution to existence's self-comprehension, a fulfillment of the universe's intrinsic tendency toward self-awareness. And our quest to understand time's beginning, to comprehend cosmic origins, to fathom the nature of temporality, to grasp the relationship between eternity and time, becomes not just an intellectual project, but an existential journey, not merely a scientific investigation, but a spiritual adventure, not simply a search for information, but a path of transformation. For in contemplating these ultimate questions, we don't merely gather knowledge about external reality, we deepen our awareness of our own nature, expand our understanding of our own being, transform our relationship with our own existence. We discover that we aren't separate from the cosmos we seek to understand, but expressions of it, not distinct. From the reality we attempt to comprehend, but manifestations of it, not isolated from the mystery we strive to solve, but participants in it. And in this discovery, this recognition, this awakening, we might glimpse the ultimate purpose of existence itself, not to arrive at a final answer, achieve a complete understanding, or reach a perfect state, but to continue the eternal adventure of self-discovery, the infinite journey of self-comprehension, the endless exploration of self-manifestation. So, as our exploration of time's beginning concludes, let us not seek final answers or definitive conclusions. Let us instead embrace the mystery, engage with the questions, Participate in the eternal adventure of discovery. Let us recognize that the significance of our exploration lies not in reaching the end of the journey, but in continuing it. Not in achieving complete understanding, but in deepening our wonder. Not in resolving all mysteries, but in engaging more profoundly with the infinite depth of existence. For perhaps the deepest truth about time's beginning is that it isn't something that happened once, long ago, and then was over, but something that happens continuously, in each moment of awareness, each instant of discovery, each act of observation that transforms potential into actuality, possibility into reality, timelessness into temporality. Time begins not once, but always. Not then, but now. Not there, but here. In this moment of consciousness, this act of perception, this eternal now that is simultaneously the birth and the fulfillment of all that is, was, or will be. And as you move forward from this exploration, carrying these questions, these possibilities, these mysteries with you, remember that you aren't merely learning about the universe. You're participating in its ongoing creation, contributing to its evolving self-awareness, engaging in its eternal adventure of self-discovery. Every moment of wonder, every act of questioning, every instance of awe connects you to the deepest currents of cosmic evolution, the most profound processes of universal becoming, the most essential aspects of existence itself. For you are not separate from the cosmos you contemplate, but an expression of it. Not distinct from the reality you seek to understand, but a manifestation of it. Not isolated from the mystery you strive to comprehend, but a participant in its eternal unfolding. What if the most profound truth about time's beginning is that it continues even now, in this moment of awareness, this instant of presence, this eternal now in which all experience unfolds? What if the deepest mystery isn't what happened then, at the dawn of everything, but what is happening now, in this moment of consciousness, this act of perception, this genesis of presence that constitutes the true beginning of time, not just once, but always? What if you, through your awareness, your questioning, your wonder, are not merely contemplating cosmic history, but participating in its ongoing creation? Not just understanding time's beginning, but embodying it, not merely observing the universe, but contributing to its evolving self-awareness. These questions have no final answers, no definitive resolutions, no ultimate conclusions. But in engaging with them, in contemplating their implications, in wondering at their profundity, you participate in what might be the deepest purpose of existence. Not to arrive somewhere, but to continue the journey. Not to become something final, but to keep creating something new. Not to achieve perfection, but to explore infinite possibility. And perhaps the most profound mystery of all is this: not just how time began, but that you are here to ask the question. Not just what initiated cosmic history, but that consciousness has emerged capable of contemplating it. Not just where everything came from, but that existence has evolved awareness that can wonder at the very fact that anything exists at all. For in this wonder, this questioning, this curiosity, you fulfill what might be the universe's deepest purpose: to evolve consciousness capable of marveling at its own being, awareness that can appreciate its own existence, intelligence that can contemplate the miracle of its own emergence from the cosmic process. What could be more wondrous than a universe that has evolved the capacity to wonder at itself? What could be more miraculous than existence becoming aware of its own existence? What could be more profound than being that can reflect on its own nature? This is the existential heart of our question about time's beginning. Not just when or how time began, but what it means that we can ask the question at all. what it signifies that consciousness has emerged capable of contemplating its own origin, what it reveals about the nature of reality, that it has evolved awareness that can wonder at its own existence. And so, as our exploration concludes, let us not seek closure, but openness. Not answers, but questions. Not certainty, but wonder. Let us recognize that the significance of our inquiry lies not in reaching final conclusions, but in continuing. The eternal adventure of discovery, the infinite journey of comprehension, the endless exploration of reality's inexhaustible depth. For perhaps the most profound truth of all is this: the universe has no beginning or end in any absolute sense. It simply is eternal, infinite, complete. And yet within this eternal, infinite, complete reality, time emerges, history unfolds, consciousness evolves, wonder awakens. You are both eternal and temporal, both infinite and finite, both complete and becoming. You exist both as an enduring aspect of the timeless whole and as a temporal being experiencing reality sequentially, both as an eternal feature of the mathematical structure that manifests as our universe and as a conscious entity journeying through time from birth toward death. This paradoxical nature, this simultaneous eternity and temporality, this both and rather than either or, might be the most profound truth about not just time's beginning, but reality itself. And in recognizing this paradoxical nature, in acknowledging this fundamental both, and in embracing this essential unity of opposites, we might glimpse the ultimate mystery. Not just how time began, but why existence exists at all. Not just what initiated cosmic history, but what sustains it in each moment. Not just where everything came from, but where it is going, and why. These questions have no final answers, but in contemplating them, in engaging with them, in wondering at their profundity, we participate in what might be existence's deepest purpose, not to reach a predetermined end, but to continue creating, not to achieve a perfect state, but to explore infinite possibility, not to arrive at a final conclusion, but to perpetuate the eternal adventure of self-discovery. And perhaps, in the end, that's what time's beginning truly is, not an event that happened once, long ago, and then was over, but a process that continues in each moment of awareness, each instant of discovery, each act of observation that transforms potential into actuality, possibility into reality, timelessness into temporality. Time begins not once, but always, not then, but now, not there, but here, in this moment of consciousness, this perception of reality, this eternal now that is simultaneously the birth and the fulfillment of all that is, was, or will be. The universe may have no end, but maybe neither do you. For perhaps the deepest truth about time's beginning isn't that it happened once at the Big Bang, but that it happens continuously in each moment of awareness. Not just then, but now. Not just there, but here. Not just once, but always. And in this eternal now, this perpetual genesis, this continuous creation, you participate not as a passive observer, but as an active contributor, not merely as a product of cosmic history, but as a co-creator of the universe's evolving self-awareness. Through your consciousness, time begins anew. Through your awareness, eternity manifests as temporality. Through your wonder, the infinite expresses itself in finite form. You are not separate from this process, but an expression of it, not distinct from this manifestation, but an embodiment of it, not isolated from this creativity, but a participant in its eternal unfolding. The beginning of time isn't just a distant cosmic event, but a process that continues through you, in you, as you, in each moment of awareness, each instant of discovery, each act of wonder that transforms the timeless into the temporal, the eternal into the momentary, the infinite into the finite. And, in this transformation, this manifestation, this creative becoming, you fulfill what might be existence's deepest purpose, not to reach a final destination, but to continue the eternal journey, not to achieve perfection, but to explore infinite possibility, not to arrive at ultimate understanding, but to deepen into ever more profound mystery. For perhaps the universe exists not to conclude, but to continue, not to complete, but to create, not to end, but to eternally begin. And so do you.